In the depths of space, where silence reigns eternal and darkness stretches beyond human comprehension, something stirs. Tonight, as you look up at the star-scattered canvas above, Mars hangs like a crimson jewel against the void closer than it has been in years. Brighter than memory serves, pulsing with an ancient light that has captivated humanity since we first lifted our eyes to the heavens. But Mars is not alone tonight. Astronomers around the world have been tracking something extraordinary, an interstellar wanderer designated 3I Atlas, a visitor from the vast spaces between the stars. Like a cosmic messenger bearing news from distant suns, it sweeps through our solar system on a trajectory that will bring it tantalizingly close to the red planet. Yet what has captured the attention of observatories from Chile to Hawaii is not the object itself, but what appears to be happening around it. The photographs are puzzling, almost unsettling in their implications. Where once there was a single point of light moving against the stellar backdrop, now there are more. Bright fragments, debris, or perhaps something else entirely, multiplying in the darkness like seeds scattered by an invisible hand. The images show a growing constellation of objects, each one glowing with reflected sunlight, each one defying simple explanation. Dr. Sarah Chun, observing from the Mauna Kea Observatory, described it in terms that border on the poetic. It's as if 3I Atlas is shedding pieces of itself, leaving a trail of light in its wake. But the pattern, there's something almost deliberate about it. What could cause an interstellar object to fragment in such a way? Natural explanations abound: the stress of solar radiation, gravitational forces, the simple mechanics of an ancient body finally succumbing to the journey between worlds. Yet as the observations continue, as more telescopes turn their gaze toward this cosmic ballet, questions multiply alongside the mysterious objects themselves. Is this merely the death throes of a wandering comet, its icy heart finally surrendering to the solar wind? Or could we be witnessing something far more profound, a phenomenon that challenges our understanding of what moves through the spaces between stars? The ancient Romans would have seen omens in such a display. They watched Mars with fearful reverence, naming it for their god of war, reading messages of conflict and change in its crimson wanderings across the sky. Now, as Mars glows with unusual intensity and mysterious objects multiply in its vicinity, one cannot help but wonder what messages the cosmos might be writing across the darkness. Tonight, as 3I Atlas continues its inexorable approach toward Mars, observatories around the world maintain their vigil. Each photograph reveals new details, new questions, new fragments of light that seem to dance around the visitor from deep space. The multiplying objects catch and reflect the distant sun's radiance, creating a slowly expanding constellation that grows brighter with each passing hour. There is something deeply unsettling about watching objects multiply in the emptiness of space. It goes against our understanding of how things should behave in the cosmic void, where every particle of matter is precious, where nothing should appear without cause or purpose. Yet here they are, growing in number, growing in brightness, growing in mystery. As we stand on the threshold of discovery, peering through our most powerful telescopes at this unfolding drama, we cannot shake the feeling that we are witnessing something significant. Perhaps it is merely the spectacular end of an ancient traveler, a cosmic fireworks display played out across millions of miles. Or perhaps we are seeing something that will fundamentally change how we view our place in the universe. The red glow on the horizon grows stronger with each passing night, and the multiplying objects continue their silent dance around 3IS LASLS. Whatever answers await us lie hidden in the growing constellation of light that follows this interstellar messenger on its journey toward Mars. But to understand what we might be witnessing, we must first journey back to the beginning, to the moment when humanity first realized we were not alone in receiving visitors from the stars. The story of interstellar visitors begins not with 3I Tile Sile, but with a moment of profound revelation that occurred on a quiet October morning in 2017. Dr. Robert Warwick, scanning data from the Panoramic Survey Telescope and Rapid Response System in Hawaii, noticed something that shouldn't have. Existed a faint streak of light moving through space on a trajectory, unlike anything in our solar system's family of objects. This was Oumuamua, a name that means scout or messenger in Hawaiian, and it would become humanity's first confirmed visitor from interstellar space. Unlike the comets and asteroids that call our sun home, Oumuamua had come from somewhere else entirely, perhaps from the Vega system, perhaps from regions even more distant and unknown. What made Oumuamua so extraordinary was not just its origin, but its behavior. As astronomers tracked its tumbling journey through our solar system, they discovered it was accelerating in ways that defied conventional physics. It moved like a comet, yet showed no visible tail of gas and dust. It reflected light like a metallic surface, yet seemed to be spinning in a chaotic dance that suggested either an extremely elongated shape or something far stranger. For months, the scientific community debated what they had witnessed. Was Oumuamua a shard of some distant planet, blasted into space by an ancient collision? Was it a comet so old that its volatile materials had long since been stripped away? Or could it have been something else entirely? Perhaps even an artifact of intelligence, a probe sent by minds we have yet to encounter. 2 years later, in August 2019, amateur astronomer Gennady Borisov discovered another interstellar wanderer, 2I Borisov. This second visitor behaved more like a traditional comet, developing a spectacular tail as it approached the sun, reassuring astronomers that not all interstellar objects would prove as enigmatic as their first confirmed guest. Yet 2I Borisov carried mysteries of its own. Analysis of its composition revealed materials unlike anything found in our solar system isotopic ratios that spoke of formation under alien suns, in stellar nurseries separated from our own by unimaginable gulfs of space and time. It was a chemical messenger, carrying in its frozen heart the signatures of worlds we may never visit. Now comes 3I Elias, the third confirmed interstellar visitor, and already it has begun to demonstrate that each of these cosmic messengers brings its own unique puzzle. Where Oumuamua tumbled and accelerated mysteriously, where Borisov behaved like a familiar comet in an unfamiliar package. 3.1 Elias presents us with something entirely new, the phenomenon of multiplication. The earliest observations showed nothing unusual. 3.1 Elias is a single point of light, following a hyperbolic trajectory that marked it clearly as another visitor from beyond our solar system. Its brightness suggested a modest-sized object, perhaps a few hundred meters across, large enough to survive the journey between stars, small enough to have escaped detection until its relatively close approach to our sun. But as weeks passed and more powerful telescopes turned their attention to the visitor, something began to change. The single point of light began to show structure, then fragmentation, then what could only be described as multiplication. Where once there had been one object, now there were several. Where there had been several, now there were dozens. Dr. Elena Vasquez, imaging specialist at the European Southern Observatory, described the progression with barely contained excitement. Each night brought new surprises. It was as if 3I Atlas was awakening from some deep slumber, coming alive as it journeyed deeper into our solar system. The multiplication wasn't random. There seemed to be patterns, almost like a code being written across the darkness. Unlike the spectacular fragmentation events we sometimes witness with comets' violent breakups that scatter debris in chaotic clouds, the multiplication around 3I Atlas appeared controlled, almost purposeful. The new objects maintained formation, moving together like a coordinated fleet rather than the random scattering of destroyed material. This behavior sets 3I Atlas apart not just from Oumuamua and Borisov, but from every interstellar object we've ever theorized about. Comets fragment, yes, but they do so under stress, under the intense radiation and gravitational forces of close solar approach. 3180 LAS began its multiplication while still far from the Sun, in the cold depths where such dramatic changes should not occur. As the object continues its approach toward Mars, the multiplying fragments have begun to show individual characteristics. Some appear brighter than others. Some seem to move with subtle independence while maintaining the overall formation. Spectroscopic analysis has revealed that they share similar surface compositions, yet each fragment reflects light with slight variations that suggest either different orientations or different materials entirely. The implications are staggering. If 3Ia Tiloa as truly is multiplying rather than simply fragmenting, we may be witnessing a phenomenon that challenges our understanding of how matter behaves in the depths of space. Objects don't simply create copies of themselves without energy input, without some driving mechanism that we have yet to identify or understand. As 3Ia Tiloa draws closer to Mars, as the red planet grows larger in its path, the multiplying objects continue their mysterious dance. Each new observation brings fresh questions, fresh possibilities, fresh reasons to wonder whether we are truly prepared for what these interstellar messengers might reveal about the nature of the cosmos and our place within it. Yet even as scientists work to understand this unprecedented phenomenon, whispers begin to circulate through the astronomical community, stories of observations that don't quite fit the official reports, of data that suggests something far stranger than simple fragmentation. In the quiet hours before dawn, when the world sleeps and only the most dedicated astronomers remain at their posts, conversations take on a different quality. The formal language of scientific papers gives way to something more personal, more uncertain, more human. It is in these moments, between the official observations and published reports, that the real story of 3i Atlas begins to emerge. Dr. Marcus Webb, a veteran observer at the Palomar Observatory, was among the first to notice what he would later describe as the impossible brightness variations. Working the midnight shift on a particularly clear February evening, he watched through the eyepiece as 3i Atlas seemed to pulse with its own internal rhythm. Not the steady, predictable changes one might expect from a tumbling object catching and releasing sunlight, but something that seemed almost deliberate. "I've been watching the skies for 30 years, Webb confided to a colleague over coffee in the observatory break room. "I've seen comets fragment, asteroids collide, and every kind of natural phenomenon you can imagine. But this felt different. It was as if the object was trying to communicate something." His colleague, Dr. Yuki Tanaka, had her own story to tell. While analyzing spectroscopic data from the Subaru telescope, she discovered absorption lines that appeared and disappeared seemingly at random. The spectrum would be normal 1 hour, showing typical rocky composition, and then suddenly we'd see elements that shouldn't exist in an interstellar object. Technetium signatures, complex carbon chains that looked almost manufactured. These anomalies might have been dismissed as instrumental errors or atmospheric interference, but they were occurring across multiple observatories, on different continents, using entirely different equipment. When Dr. Chun from Mauna Kea compared her observations with those from Chile's Very Large Telescope, the patterns matched with unsettling precision. The multiplication phenomenon itself seemed to follow no natural law that anyone could identify. Traditional comet fragmentation occurs under predictable circumstances. Solar heating causes volatile materials to outgas, creating pressure that can split a fragile nucleus. Gravitational stress from close planetary encounters can tear objects apart. But 3i Atlas was multiplying in the cold depths of space, far from any obvious trigger. "We started calling them daughters," admitted Dr. Sarah Okafor from the Arecibo Observatory, referring to the smaller objects that seemed to spawn from the main body. Each new fragment was smaller than its parent, but they all maintained the same basic spectral signature. It was as if they were being manufactured rather than broken off. The really disturbing observations began arriving from radio astronomy facilities. The Very Large Array in New Mexico detected structured signals in the background noise around 3IA, Cell A, not random static, but patterns that repeated with mathematical precision. Dr. James Morrison, analyzing the data, found sequences that followed prime number progressions, mathematical constants, even what appeared to be geometric relationships. We're not talking about little green men broadcasting hello across the cosmos, Morrison explained to a hastily convened panel of colleagues. These signals were subtle, embedded in what should have been natural radio emissions from the object, but the patterns they're too complex to be coincidental. The story began to leak beyond the tight-knit community of professional astronomers. Amateur observers, using increasingly sophisticated equipment, started reporting their own anomalies. Marcus Rivera, operating a modest telescope from his backyard in Arizona, photographed what he described as synchronized flashing. Among the multiplying objects, brief, coordinated bursts of reflected light that seemed to ripple through the formation, like signals passing from one fragment to another. Online forums dedicated to astronomy buzzed with speculation and blurry photographs. Videos appeared on social media, showing the growing constellation of objects around 3IA Tele, each one generating hundreds of comments from viewers convinced they were witnessing something unprecedented. The hashtag multiplying objects began trending among space enthusiasts, accompanied by increasingly elaborate theories about what they might be observing. But perhaps the most unsettling reports came from observatories that chose not to publish their findings. Dr. Elizabeth Zhao, working at a classified facility that monitors space for potential threats, spoke only in careful euphemisms when contacted by colleagues. Let's just say that certain observations have been flagged for further review, she said. There are aspects of this phenomenon that require ... discretion. Government space agencies, typically eager to share discoveries that capture public imagination, remained unusually quiet about 3IA. NASA's official statements spoke only of ongoing observations and preliminary data analysis. The European Space Agency issued similarly vague updates, always promising more detailed information, pending further study. This official reticence only fueled speculation among the astronomical community. If 3IA TLAS were simply an unusually active comet, why the hesitation to share findings? Why were certain observatories being asked to limit their public statements about the object? Dr. Ahmed Hassan, coordinator for the International Astronomical Union's Committee on Interstellar Objects, found himself fielding increasingly frustrated calls from colleagues around the world. Everyone wants answers, he explained to his staff during an emergency meeting. But we're dealing with observations that don't fit any existing model. Every time we think we understand what's happening, new data arrives that changes everything. The folklore was already beginning to form. Stories circulated of night shift astronomers who claimed to have seen the multiplying objects arrange themselves into geometric patterns, triangles, pentagons, formations that suggested intelligence and purpose. Others reported objects that seemed to respond to observation, growing brighter when telescopes were pointed in their direction, dimming when attention shifted elsewhere. Some observers began to feel watched, though they struggled to articulate exactly what they meant. Dr. Webb described it as sensation of being studied while you're trying to study something else. It's probably just psychological, the result of spending too many nights staring at something so strange. But the feeling persists. As spring approached and 3IA Atlas continued its trajectory toward Mars, the whispers in observatory break rooms grew more urgent, more concerned. Whatever they were witnessing was accelerating, becoming more complex, more difficult to explain through conventional science. The multiplying objects were no longer just fragments. They had become a mystery that challenged the very foundations of how we understand matter and motion in the depths of space. Yet as humanity grappled with these unprecedented observations, the stage was being set for an even greater mystery. For 3I, Aviles was not approaching just any celestial body, it was heading toward Mars, the red world that has haunted human imagination since the dawn of civilization. Mars has always been different. Even to the naked eye wandering across the star-filled dome of night, it pulses with a light unlike any other planet. Ruddy blood-red beacon that has stirred something primal in human consciousness since our ancestors first gathered around fires and looked up at the heavens in wonder and fear. The ancient Babylonians called it Nergal, after their god of war and plague. The Greeks named it Ares, for their deity of battle and bloodshed. To the Romans, it was Mars the Red Wanderer, whose movements across the sky foretold conflicts and upheavals on Earth below. In Chinese astronomy, it was known as the Fire Star, a celestial harbinger of drought and famine. Across cultures, across continents, across millennia, this crimson world has been associated with transformation, with endings, with the kind of cosmic events that reshape civilizations. Now, as 3I Tele, its multiplying companions approach this ancient symbol of change, we cannot help but feel the weight of that symbolism pressing down upon us. Of all the destinations in our solar system, why Mars? Why is this unprecedented interstellar phenomenon unfolding in the vicinity of the one world that has captured human imagination more completely than any other? Mars occupies a unique place in our collective consciousness, close enough to Earth that we can envision reaching it, similar enough to our own world that we can imagine living there, yet alien enough to represent the ultimate frontier. It is the planet of dreams and nightmares, of scientific ambition and science fiction speculation. It is where we have projected our hopes for expansion beyond Earth and our fears of what we might find when we finally leave our home world behind. The Red Planet has been the stage for countless stories of invasion and exploration, of ancient civilizations and future colonies. H.G. Wells chose Mars as the origin point for his war machines in The War of the Worlds, establishing a literary tradition that cast the Red Planet as humanity's greatest existential threat. Ray Bradbury transformed it into a haunting elegy for lost civilizations in The Martian Chronicles, while Kim Stanley Robinson used it as the canvas for humanity as greatest terraforming epic in his Mars trilogy. But Mars is more than just the stuff of fiction. It represents our species' next great leap into the cosmos, the first world we will attempt to inhabit beyond our own. NASA's rovers have been roaming its surface for decades, analyzing its soil, studying its weather patterns, searching for signs that life once existed in its ancient seas. SpaceX has made Mars the ultimate destination for its ambitious colonization plans, with Elon Musk envisioning cities of 1 million people thriving beneath its butterscotch skies. Every 26 months, when Mars reaches opposition, its closest approach to Earth, the planet grows noticeably brighter in our night sky, sometimes outshining even Jupiter in its ruddy brilliance. During these oppositions, Mars looms large in telescopes, revealing its polar ice caps, its vast canyon systems, its towering volcanic peaks. It becomes, for a few precious weeks, almost close enough to touch. This current opposition is particularly significant. Mars is not just at its closest approach to Earth in years, but it's reaching this proximity just as 3I Attilae arrives in its vicinity. The timing seems almost orchestrated, as if the cosmos itself has arranged for humanity to witness this interstellar phenomenon. Against the backdrop of our most mythologically significant neighbor, Dr. Patricia Reeves, a planetary scientist at JPL, has been studying Mars for over 2 decades. As she watches the approach of 3I Lyce, she can't shake the feeling that the timing is more than coincidental. Mars has always been a world of mysteries, she observes. We found evidence of ancient rivers, possible microbial life, geological processes we still don't fully understand. Now we have these multiplying objects approaching it, and I can't help but wonder if Mars itself might be somehow ... involved. The planet's own behavior has been subtly unusual during this opposition. The massive dust storms that typically develop during Martian spring have been more intense than predicted, obscuring surface features that rovers and orbiters usually monitor with precision. The planet's magnetic field, normally weak and patchy, has shown unexplained fluctuations that correlate strangely with the approach of 3I Al. Some researchers have noted that Mars's two small moons, Phobos and Deimos, appear to be reflecting light differently in recent weeks. Spectroscopic analysis suggests changes in surface composition that shouldn't occur on such geologically stable bodies. It's as if the entire Martian system is responding to the approaching interstellar visitor in ways that conventional astronomy cannot explain. The mythology becomes even more intriguing when we consider that Mars has long been associated not just with war, but with revelation, with the uncovering of hidden truths. In astrological traditions, Mars governs not only conflict, but also the courage needed to face difficult realities. It is the planet that forces us to confront what we would rather avoid, to acknowledge what we would prefer to deny. Indigenous astronomical traditions also speak of Mars as a messenger. The Lakota called it the star that brings changes, while Australian Aboriginal peoples saw it as a celestial ancestor warning of transformations to come. Polynesian navigators used Mars as a timing marker for long voyages, understanding that its appearances coincided with periods when the familiar became unfamiliar, when old certainties gave way to new possibilities. As 3I Atlas continues its approach, carrying its mysterious cargo of multiplying objects, we find ourselves confronting the same themes that have always surrounded Mars transformation: revelation, the courage to face the unknown. The red planet seems to be calling to us across the void, its ancient light mixing with the strange new radiance of the multiplying fragments that dance around our interstellar visitor. Perhaps it is mere coincidence that humanity's first encounter with a truly anomalous interstellar phenomenon should occur in the vicinity of Mars. Perhaps the timing is random, the destination arbitrary, the symbolic weight we attach to it, nothing more than pattern-seeking behavior evolved from millions of years of trying to make sense of a chaotic universe. Or perhaps Mars has always been exactly what our ancestors believed it to be: a herald of change, a cosmic stage where the most significant dramas of existence unfold, a red eye watching over humanity as we take our first tentative steps toward understanding our place in a universe far stranger and more wonderful than we ever dared imagine. The ancient Romans believed that when Mars grew bright in the sky, the fates of nations hung in the balance. Now, as the red planet blazes with unusual intensity and mysterious objects multiply in its vicinity, we cannot help but wonder what fate awaits us all. Yet even as we contemplate the mythic significance of this cosmic convergence, science demands that we seek rational explanations for what we're witnessing. The multiplying objects around 3I Atlas may hold secrets that transform our understanding of how matter behaves in the depths of space. In the sterile glow of computer screens and the quiet hum of analysis equipment, science seeks to impose order on the chaos of the unknown. As reports of multiplying objects around 3I Atlas continue to accumulate, researchers worldwide have turned to the fundamental principles of physics and chemistry to explain what should, by all conventional understanding, be impossible. Dr. Michael Zhang, a specialist in cometary dynamics at the Harvard-Smithsonian Center for Astrophysics, leads one of the primary teams attempting to model the fragmentation process. His initial hypothesis follows established science. 3I Atlas, like many comets, contains volatile materials: water ice, frozen carbon, dioxide, methane, and other compounds that remain stable in the frigid depths of interstellar space, but begin to sublimate as they approach the warmth of our sun. The basic physics is straightforward, Zhang explains. gesturing at computer simulations that show a virtual comet nucleus gradually shedding material as it heats up. Solar radiation causes the surface layers to warm. Volatile materials transition directly from solid to gas, and the resulting outgassing creates pressure that can fragment a structurally weak nucleus. We see this behavior regularly with short-period comets in our own solar system. The YORP effect, named for Yarkovsky-O'Keefe-Radzievsky Paddock, provides another potential explanation. This phenomenon occurs when thermal radiation from an object's surface creates tiny but persistent forces that can alter its rotation rate over time. For a fragile interstellar body, already stressed by the journey between stars, increased rotation might provide the centrifugal force necessary to tear it apart. Computer models based on these principles can indeed produce fragmentation patterns that superficially resemble what astronomers are observing around 3I A Tel A S virtual comet nuclei split into smaller pieces, which then undergo their own fragmentation cycles, creating cascading effects that could theoretically account for the multiplication phenomenon. Dr. Elena Vasquez, working with the most detailed observational data from the European Southern Observatory, has identified what appear to be classic cometary features around many of the fragments. Spectroscopic analysis reveals the signatures of water vapor, carbon monoxide, and other volatiles that would be expected from sublimating ice. Some fragments display faint comas, the fuzzy atmospheres that form around comet nuclei as they release gas and dust. When we look at the individual fragments through our most powerful instruments, Vasquez notes, many of them behave exactly as we would expect small cometary bodies to behave. They outgas, they develop tails oriented away from the sun. They follow predictable trajectories based on gravitational mechanics and radiation pressure. Gravitational effects provide yet another avenue for explanation. As 3I S travels through our solar system, it experiences the combined gravitational influences of the sun, planets, and other bodies. These tidal forces could stress the object's internal structure, creating fractures that eventually lead to complete fragmentation. The process might be gradual, explaining why the multiplication appears to occur over an extended period rather than in a single catastrophic event. Laboratory experiments support these theoretical models. Researchers have subjected samples of various ice and rock composites to conditions that simulate the interstellar environment, then expose them to gradual warming and gravitational stress. Many samples fragment in patterns remarkably similar to what's being observed around 3I Atlas, complete with the production of secondary and tertiary fragments as the fragmentation cascade continues. Dr. Jennifer Walsh, a materials scientist at MIT specializing in the behavior of matter under extreme conditions, has been studying how prolonged exposure to cosmic radiation might affect interstellar objects. Over the millions of years that 3I Atlas has been traveling through space, high-energy particles would have gradually altered its internal structure, she explains. The bombardment creates microscopic fractures, weakens crystalline bonds, and essentially pre-stresses the material. When it finally encounters the thermal and gravitational environment of our solar system, fragmentation becomes almost inevitable. The dust and debris fields that surround many comets could also create optical illusions that make fragmentation appear more dramatic than it actually is. Individual particles, too small to resolve with current telescopes, might cluster in ways that create the appearance of discrete objects. Changes in the density or distribution of this debris could make it seem as though new fragments are materializing when, in reality, existing material is simply becoming more visible. Advanced computer simulations incorporating these various factors can produce remarkably convincing reproductions of the 3I Astronomy phenomenon. Virtual interstellar objects, programmed with realistic physical properties and subjected to the gravitational and thermal environment of our solar system, fragment in complex patterns that match many of the observed characteristics of the multiplying objects. Yet even as these scientific models provide plausible explanations for what astronomers are witnessing, troubling anomalies persist in the data. The fragments appear to maintain formations that seem too stable for randomly produced debris. Their spectroscopic signatures show subtle variations that suggest compositional differences, rather than simple fragmentation of a homogeneous parent body. Most puzzling of all, the timing and pattern of the multiplication events display regularities that natural fragmentation processes should not produce. Dr. Zhang acknowledges these inconsistencies with the careful language of a scientist unwilling to venture too far beyond established fact. The models work well for explaining perhaps 70 to 80% of what we're observing, he admits, but there remain aspects of the phenomenon that don't fit neatly into our current understanding of cometary behavior. These anomalies could represent gaps in our knowledge of how interstellar objects behave, or they might point toward processes we haven't yet identified. The scientific method demands that researchers remain open to multiple possibilities, even when some of those possibilities challenge fundamental assumptions about how the universe operates. While conventional fragmentation processes can account for much of what's happening around 3I Atlas, the unexplained elements in the data continue to generate debate and speculation within the astronomical community. As observations continue and more sophisticated analysis techniques are applied to the growing dataset, the picture becomes simultaneously clearer and more mysterious. Each new piece of evidence supports certain aspects of the fragmentation hypothesis, while raising fresh questions about others. The multiplying objects around 3I Est at the boundary between the known and unknown, where established science meets the vast realm of cosmic possibilities we have yet to explore. But even as scientists work to explain the multiplication phenomenon through conventional physics, other observers have begun to detect anomalies that suggest the story of 3I Atlas may be far more complex than simple fragmentation. In the sprawling antenna arrays that dot remote landscapes around the world, radio astronomers spend their nights listening to the universe's most subtle whispers. They sift through cosmic background radiation, pulsar signals, and the electromagnetic chatter of distant galaxies, searching for patterns in what most would consider mere noise. It was in this realm of careful signal analysis that the first hints emerged that 3I Atlas might be more than just another fragmenting comet. Dr. Rebecca Santos had been monitoring routine radio emissions from the interstellar visitor when she noticed something that made her pause her late-night data review. Working at the Arecibo Observatory during its final months of operation, she was analyzing broadband radio observations when subtle patterns began to emerge. From the background static patterns that followed mathematical progressions too precise to be natural. At first, I thought it was interference from our own equipment, Santos recalls, her voice carrying the measured caution of a scientist who has learned to question everything. Radio telescopes are sensitive instruments, and we're constantly filtering out signals from cell phones, satellites, even microwave ovens in nearby towns. But these patterns were different. They were embedded in the natural radio emissions from the object itself. The signals were not the dramatic, clearly artificial transmissions that SETI researchers dream of discovering. Instead, they appeared as subtle modulations in the electromagnetic radiation that any large object in space naturally emits. It was as if someone or something had found a way to encode information into the random thermal noise that should have been emanating from 3I alias Dr. James Morrison at the Very Large Array in New Mexico had been conducting his own independent analysis when he stumbled upon similar anomalies. Working with terabytes of observational data, he developed algorithms to filter out known sources of interference and isolate the radio signature of the interstellar visitor. What he found challenged his understanding of how electromagnetic radiation behaves in the depths of space. The signal carried structured information, Morrison explains, pulling up waterfall displays that show radio frequency patterns cascading down his computer screens like digital rain. We found sequences that matched prime number progressions: 2, 3, 5, 7, 11, 13. Then mathematical constants like pi and the golden ratio, encoded in the timing intervals between radio pulses. These aren't the kind of patterns that emerge from natural physical processes. The most intriguing discovery came when Morrison began analyzing the radio emissions from the individual fragments that were multiplying around the main body of 31A. Telluriide to contribute its own component to the overall signal, like instruments in some vast cosmic orchestra. When combined, these individual contributions created interference patterns that produced even more complex mathematical relationships. We started calling it the fragmentation symphony, Morrison admits with a slight smile. Each new object that appeared seemed to add another voice to the composition. The resulting harmonics created frequency patterns that spelled out geometric relationships. The ratios between the sides of regular polygons, the mathematical relationships underlying three-dimensional forms. Independent verification came from radio observatories on 3 different continents: the Effelsberg Radio Telescope in Germany, the Parkes Observatory in Australia, and the Green Bank Telescope in West Virginia. All detected similar structured patterns in their observations of 3I, A till A, S. The consistency across different instruments and locations made equipment malfunction or atmospheric interference increasingly unlikely explanations. Dr. Yuki Nakamura, working with the Japanese AOMA array, discovered that the signals showed a temporal evolution that correlated precisely with the visual multiplication of objects around 31A till A S as new fragments appeared in telescopic observations. Corresponding new components emerged in the radio data. The timing was too precise to be coincidental. Whatever was causing the physical multiplication was also responsible for the growing complexity of the electromagnetic signals. It was as if each new fragment was being assigned a specific role in transmitting information, Nakamura observes. The original object provided what we might call the carrier wave, but each additional fragment modulated that signal in mathematically precise ways. The result was a communication system of remarkable sophistication. The content of these signals remained frustratingly opaque. While the mathematical relationships were clear, their meaning, if any, eluded analysis. Cryptographers and codebreakers were consulted, but the patterns seemed to exist for their own sake, rather than to convey specific information. It was as if the signals were designed to demonstrate intelligence without actually communicating anything concrete. Some researchers began to suspect that the signals themselves might be less important than their mere existence. Dr. Sarah Okafor, coordinating international radio astronomy efforts, proposed that the structured emissions might serve as a kind of cosmic signature, a way of identifying the fragments as something other than natural debris. If you wanted to mark objects in space as artificial or controlled, embedding mathematical patterns in their radio emissions would be an elegant solution, Okafor suggests. Any technologically advanced civilization monitoring radio frequencies would recognize the patterns as indicators of intelligence, even if they couldn't decode the specific meaning. The timing of these discoveries created additional layers of mystery. The structured radio signals had not been present during the earliest observations of 31 Allele S. They seemed to have emerged gradually, becoming more complex and sophisticated as the object approached closer to our Sun. It was as if proximity to our solar system had somehow activated dormant communication systems. Analysis of historical radio astronomy data revealed tantalizing hints that similar signals might have been present during the passage of previous interstellar visitors. Archived observations of Oumuamua showed potential mathematical patterns that had been dismissed as instrumental artifacts at the time. 2I Borisov displayed subtle radio characteristics that, when reanalyzed using techniques developed for studying 3I LA structured components. We may have been receiving messages for years without recognizing them, scientists realizes with a mixture of excitement and concern. The signals are so subtle, so carefully integrated into natural radio emissions, that they could easily be overlooked unless you knew exactly what to search for. Government agencies tasked with monitoring potential security threats began taking notice of these findings, while the astronomical community continued to debate the natural versus artificial origin of the signals. Classified facilities started conducting their own analysis of the radio emissions from 3I TLA ESA. The results of these investigations remained highly restricted, adding another layer of mystery to an already perplexing phenomenon. As the interstellar visitor continued its approach toward Mars, the radio signals grew stronger and more complex. New mathematical relationships emerged with each passing week, creating an ever-expanding library of encoded information that challenged the processing capabilities of even the most sophisticated computer systems. Whatever was generating these signals possessed a mathematical sophistication that rivaled humanity's greatest achievements in abstract mathematics. The static was no longer just static. Hidden within the cosmic background noise, patterns of incredible complexity suggested that 3I Atlas and its multiplying companions might be far more than fragments of an ancient comet. They might be carriers of intelligence, ambassadors from realms of space and time that humanity was only beginning to comprehend. Yet as modern science grappled with these unprecedented radio discoveries, ancient human traditions offered their own explanations for mysterious signals from the sky warnings and omens that our ancestors read in the movement of celestial objects across the star-filled dome of night. Long before radio telescopes captured structured signals from the depths of space, before computers decoded mathematical patterns in cosmic static, human beings looked up at the night sky and understood that the heavens were speaking to them. In the flickering light of ancient fires, under star-filled domes unmarred by the glow of electric cities, our ancestors developed sophisticated systems for reading the messages written across the darkness. The Babylonians, perhaps the most meticulous sky watchers of the ancient world, maintained detailed records of celestial phenomena for over 1,000 years. On clay tablets that survived the rise and fall of empires, they documented not just the regular movements of planets and stars, but the anomalies, the unexpected appearances, the strange multiplications, the objects that seemed to fragment and divide in the heavens above. One tablet, discovered in the ruins of the library at Nineveh and dating to approximately 650 BCE, describes what the scribes called the multiplication of Nergal's servants. According to the cuneiform text, observers reported that the Red Wanderer, their name for Mars, was accompanied by lesser lights that increased in number like the offspring of the storm god, appearing where none had been before, moving in formation like celestial soldiers preparing for battle. The tablet goes on to record the observations of the royal astronomers, who noted that these multiplying lights spoke to one another with signals of fire, flashing in patterns that repeated like the counting of temple tribute. Modern archaeologists studying this text have been struck by its precise description of what sounds remarkably similar to the coordinated light variations observed among the fragments around 3.1 Alias. In ancient China, the celestial bureaucracy was considered a perfect mirror of earthly administration, with every star and planet serving specific functions in the cosmic order. The Han Dynasty astronomical records, compiled during the 2nd century BCE, contain references to guest stars that would arrive in the vicinity of the fire star, their name for Mars, and then spawn numerous children, each carrying messages from the supreme celestial emperor. Chinese astronomers developed elaborate classification systems for these phenomena, distinguishing between natural comets, which they saw as harbingers of political change, and what they called multiplying visitors, which they associated with more profound cosmic transformations. The records describe specific protocols for observing these events, including careful documentation of how many fragments appeared, how they moved in relation to each other, and what patterns they created against the stellar background. Master Liu Xin, the great astronomer of the Han court, wrote in his treatise on the language of heaven that when the multiplying visitors appear near the fire star, they bring teachings from the realm beyond the celestial sphere. Their numbers increase according to celestial mathematics, and their movements spell out the true names of the gods who dwell in the spaces between worlds. Native American traditions offer perhaps the most sophisticated understanding of what we might now recognize as interstellar phenomena. The Hopi people of the American Southwest maintain oral histories that speak of star beings who periodically return to observe humanity's progress. According to tribal elder Robert Yazzie, these visitors come not from our family of sun and planets, but from the great darkness beyond, bringing with them fragments of their homeworlds. The Hopi prophecies describe these star beings as multiplying when they approach what they call the red world of decisions clearly, Mars in their astronomical system. The star beings divide themselves so that they may observe from many angles, Yazzie explains. Each fragment carries the consciousness of the whole, but sees with its own eyes. In this way, they ensure that no aspect of what they study remains hidden. Lakota star knowledge, preserved in the winter counts and oral traditions of the Great Plains tribes, speaks of the star that brings many, describing celestial events where single objects in the sky would divide and multiply, particularly in association with Mars during its brightest appearances. These multiplications were seen as times of great spiritual significance, when the boundaries between the physical and spirit worlds became permeable. Our grandfathers taught that when the star beings multiply near the red star, it means the Earth is being prepared for a great change, explains Joseph Horn-Elk, a keeper of traditional Lakota astronomical knowledge. The multiplication is not random. It follows patterns that match the sacred geometries we see in nature, in the spiral of shells, in the arrangement of seeds in sunflowers, in the structure of spider webs. Ancient Hindu astronomy, codified in texts like the Surya Siddhana, describes Mars known as Mangala or Angaraka as a world where divine messengers gather before undertaking journeys to other realms. The texts speak of the servants of Mangala who appear as points of light that divide like cells in the cosmic body, each one carrying the dharma of its source to new destinations among the stars. The Vedic astronomers developed mathematical models for predicting when these multiplication events might occur, based on complex calculations involving the orbital periods of Mars, the positions of other planets, and what they called the breathing of the cosmic serpent, possibly a reference to solar cycle variations that modern astronomy has only recently begun to understand. Perhaps most intriguingly, Aboriginal Australian astronomical traditions describe what they call the spawning of sky ancestors, events where spirit beings traveling between worlds would multiply themselves to ensure their wisdom reached as many locations as possible. These traditions, maintained through 50,000 years of oral transmission, speak of specific geometric patterns created by multiplying sky objects triangles, spirals, and nested polygons that match remarkably closely the formations being observed around 3Ia Tla S. The Wardaman people of the Northern Territory maintain detailed knowledge of what Elder Bill Udumduma Harney calls the visitor protocols, the ways in which sky beings announce their presence and intentions through the arrangement and behavior of celestial objects. According to these traditions, multiplication near Mars indicates that the visitors are preparing to establish long-term observation posts in our solar system. When the sky beings multiply, they are planting seeds of consciousness, Harney explains. Each new light carries part of their awareness, spreading it through the cosmos like pollen on the wind. They choose the red star as their gathering place because it stands at the boundary between the worlds we can reach and the worlds that remain beyond our grasp. These ancient traditions, developed independently across continents and millennia, share remarkable consistencies in their descriptions of multiplying celestial phenomena. They speak of intelligence, of purpose, of mathematical patterns encoded in the arrangement and behavior of objects that appear near Mars. They describe coordination between fragments, communication through light signals, and the gradual buildup of complex formations that follow geometric principles. Modern astronomers, trained to view the universe through the lens of physics and chemistry, might dismiss these ancient accounts as mythology or misinterpretation of natural phenomena. Yet as 3I Atlas continues its approach toward Mars, accompanied by its growing retinue of multiplying fragments, the parallels between current observations and these traditional descriptions become increasingly difficult to ignore. Perhaps our ancestors, unencumbered by the assumptions of mechanistic science, were able to perceive patterns and meanings in celestial phenomena that our modern instruments can detect, but our theoretical frameworks struggle to explain. Perhaps the ancient skywatchers, with their understanding of the cosmos as a living, conscious entity, recognized truths about interstellar visitors that we are only now beginning to rediscover. As 3I Atlas draws very true to Mars, carrying its mysterious cargo of multiplying objects, we find ourselves standing at the intersection of ancient wisdom and cutting-edge science, wondering if we are witnessing the return of something our ancestors knew. Visitors from the depths of space who announce their presence through the ancient language of multiplication and light. In the sterile corridors of NASA's Jet Propulsion Laboratory, where humanity's most ambitious space missions are conceived and controlled, a question has begun to haunt the conversations of engineers and theorists alike. As they watch the multiplying objects around 3I Atlas maintain their impossible formations, following trajectories that seem too coordinated for random debris, a possibility emerges that challenges every assumption about what moves through the darkness between stars. What if these objects are not fragments at all? What if they are individual units of something far more purposeful? A coordinated system designed by intelligence beyond our current understanding? Dr. Kevin Shun, a systems engineer who has spent decades designing autonomous spacecraft, was among the first to articulate what many researchers were beginning to suspect. When I look at the behavioral patterns of these objects, he explains, pulling up trajectory analyses on his workstation, I don't see the chaotic motion of debris. I see the kind of distributed coordination that we're only beginning to achieve with our most advanced drone swarms. The concept of von Neumann probes, self-replicating machines, capable of interstellar travel, has existed in theoretical physics for decades. Named after mathematician John von Neumann, who first described the mathematical foundations of self-reproducing systems, these hypothetical devices could, in theory, explore the entire galaxy within a few million years by creating copies of themselves at each star system they visit. The basic concept is elegantly simple. A probe arrives at a star system, gathers raw materials from asteroids or planetary surfaces, and uses advanced manufacturing capabilities to construct exact duplicates of itself. These new probes then continue to other star systems, repeating the process indefinitely. A single probe launched from a technological civilization could eventually populate the entire galaxy with exploratory devices, creating a vast network of intelligence gathering and communication. Dr. Sarah Nakamura, who leads JPL's Theoretical Propulsion Group, has been modeling how such probes might behave if they encountered our solar system. The multiplication pattern we're seeing around 3I Atlas fits perfectly with what we'd expect from a von Neumann system activating upon arrival, she notes. The original probe would assess local conditions, identify available resources, and begin manufacturing specialized units for different exploratory functions. The timing supports this hypothesis. 318 LA began its multiplication process not immediately upon detection, but as it drew closer to our sun and its energy sources became more readily available. Solar radiation could provide the power necessary for advanced manufacturing processes, while the solar wind might carry trace materials that sophisticated molecular assemblers could harvest and concentrate. Each new object in the formation displays slightly different characteristics, variations in brightness, spectral signature, and trajectory that suggest functional specialization rather than random fragmentation. Some appear optimized for data collection, maintaining stable orientations that would maximize sensor effectiveness. Others show evidence of propulsion capabilities, making subtle course corrections that keep them in formation with the main group. It's exactly what we'd design if we were sending an exploratory fleet to another star system, observes Dr. Maria Santos, who specializes in swarm robotics at MIT, a mothership that carries the basic manufacturing capability, specialized scouts for reconnaissance, communication relays to maintain contact across vast distances, and perhaps even defensive units to protect the mission from potential threats. The radio signals detected by observatories worldwide take on new significance under this interpretation. Rather than random electromagnetic emissions from heated cometary material, they could represent data transmission between units in an exploration fleet. The mathematical patterns embedded in the signals might be coordination protocols, status reports, or compressed scientific data being relayed back to some distant command center. Computer simulations of von Neumann probe behavior produce remarkably accurate reproductions of what astronomers are observing around 3ILX, virtual probe fleets programmed with basic exploration objectives and self-replication capabilities, form precisely the kind of coordinated formations that have been puzzling researchers. The multiplication follows logical patterns based on resource availability and mission requirements, rather than the random fragmentation expected from natural objects. Dr. James Wright, director of Penn State's Center for Exoplanets and Habitable Worlds, has been studying the implications of such technology for interstellar exploration. A civilization that developed von Neumann probes even a few thousand years ago could have spread throughout the galaxy by now. He explains, every star system could be under observation by machines so advanced that we might not even recognize them as artificial. The stealth capabilities of such probes could be extraordinary. Designed by intelligences potentially millions of years more advanced than humanity, they might be capable of mimicking natural phenomena so perfectly that only the most sophisticated analysis could reveal their true nature. The fact that 3I Atlas was initially cataloged as a comet could be entirely intentional. A camouflage system designed to avoid detection by emerging technological civilizations. If you wanted to study a developing species without influencing their natural evolution, you'd want your observation systems to appear completely natural, suggests Dr. Lisa Park, an astrobiologist at the University of Washington. Making your probes look like comets or asteroids would be the perfect cover. By the time the observed civilization became advanced enough to detect the artificial nature of the objects, they would already be technologically mature enough to handle the implications. The multiplication behavior itself could serve multiple functions within such a system. Creating numerous smaller units would provide redundancy against equipment failure or destruction. It would also allow for simultaneous observation from multiple angles and distances, creating a three-dimensional monitoring network around targets of interest, in this case, Mars and potentially Earth itself. Some researchers have noted that the timing of 3I Atlas' approach coincides with humanity's accelerating space exploration efforts. Our rovers are actively exploring Mars. Private companies are developing interplanetary transportation systems, and serious discussions of Mars colonization have moved from science fiction to engineering planning. If the multiplying objects are indeed an exploration fleet, their arrival could be timed to observe humanity's first attempts to become a spacefaring civilization. The von Neumann probe hypothesis also explains the apparent intelligence behind the radio signals without requiring active communication attempts. The mathematical patterns could be side effects of internal coordination protocols, accidentally detectable by sufficiently advanced radio astronomy. The probe designers might not have anticipated that the observed civilization would develop radio telescopes capable of detecting such subtle transmissions. Dr. Chon acknowledges the revolutionary implications of this possibility. If these objects are artificial, we're not just witnessing advanced technology, we're seeing proof that intelligence has spread throughout the galaxy. Every assumption about our cosmic isolation, about the rarity of technological civilizations, would need to be completely reconsidered. The fleet hypothesis raises profound questions about humanity's readiness for contact with galactic-scale intelligence. If 3I Atlas and its companions are indeed scouts from a civilization capable of interstellar engineering projects, what conclusions might they draw about our species? Are we being evaluated for membership in some cosmic community, or are we simply subjects of scientific study, as unaware of our observers as laboratory mice? As the multiplying objects continue their approach toward Mars, maintaining their impossible coordination and transmitting their cryptic signals, the question becomes increasingly urgent. Are we witnessing the natural death of an ancient comet, or are we under observation by intelligence beyond our current comprehension? The answer may determine not just our understanding of the universe, but our species' future within it. Yet even as we grapple with the possibility of artificial visitors, the cosmos offers us reminders that such mysteries have touched human consciousness before, recorded in the strangest accounts of our ancestors. On the morning of April 14, 1561, the citizens of Nuremberg witnessed something that defied explanation. As dawn broke over the medieval city's Gothic spires and timber-framed houses, the sky erupted into what contemporary accounts describe as nothing less than an aerial battle. Hans Glaser, a local printer, documented the event in a broadsheet that would become one of history's most enigmatic records of unexplained phenomena. According to Glaser's account, the sky filled with cylindrical shapes from which emerged black, red, orange, and blue-white spheres that appeared to fight one another. But what makes this 16th century observation particularly relevant to our current contemplation of 3I Atlas is Glaser's careful description of how these objects behaved. The spheres multiplied before the eyes of many witnesses, growing in number like seeds scattered by an unseen hand, arranging themselves in formations that spoke of purpose rather than chaos. The broadsheet preserved in the Zurich Central Library includes a woodcut illustration that shows objects arranged in geometric patterns across the sky, triangular formations, linear arrays and clustered groups that bear an unsettling resemblance to the coordinated arrangements being observed around our current interstellar visitor. Most remarkably, Glaser wrote that the spheres appeared to signal to one another with flashes of light, creating patterns that repeated like a language unknown to earthly minds. 47 years later, in August 1608, the city of Basel experienced its own celestial mystery. Local chronicles describe how great black triangular shapes appeared in the sky, from which smaller lights emerged in increasing numbers, until the heavens were filled with objects that moved with shared purpose. The Basel event was witnessed by hundreds of people, including city officials and church authorities who documented the phenomenon in official records. What sets these historical accounts apart from typical UFO sightings is their emphasis on multiplication and coordination, the same characteristics that define the 3ILA phenomenon. The witnesses didn't just report seeing strange objects. They specifically noted how these objects increased in number during the observation period, how they maintained formations that suggested intelligence, and how they appeared to communicate through synchronized light displays. Dr. Jacques Vallée, a computer scientist and researcher who has spent decades studying anomalous aerial phenomena, points out that these historical accounts contain details that wouldn't be fully understood until the development of modern astronomy. The witnesses describe behavior that matches sophisticated concepts like swarm, intelligence, and distributed coordination, he notes. These are not concepts that medieval observers would have had any framework for understanding, yet they documented them with remarkable precision. The Nuremberg and Basel events were not isolated incidents. Church records from across medieval Europe contain scattered references to multiplying stars and heavenly hosts that divided like the loaves and fishes. The Abbey of Saint Denis, near Paris, maintains chronicles that describe a 1290 event where Celestial messengers appeared in great numbers near the Red Wanderer, growing from one to many as the monks watched in prayer and wonder. In China, the Ming Dynasty astronomical records contain references to what the court astronomers called the multiplication of heaven's soldiers. A particularly detailed account from 1644 describes objects that appeared near Mars and spawned lesser lights that arranged themselves in the patterns of military formations, as if preparing for celestial warfare, or perhaps demonstrating the organizational principles of the divine bureaucracy. These historical parallels become even more intriguing when we consider that the witnesses often reported the phenomena in association with Mars during its close approaches to Earth. The red planet, already mythologically significant as a harbinger of change, seemed to serve as a gathering point for these mysterious multiplying objects across different centuries and cultures. Isabella Romano, a historian specializing in medieval astronomical records at the University of Florence, has been studying these connections. What strikes me most about these accounts is their consistency across time and geography, she observes. Witnesses separated by centuries and continents describe essentially the same phenomenon objects that multiply in the sky, maintain coordinated formations, and communicate through light signals, all in association with Mars during its prominent appearances. The technological limitations of pre-telescopic astronomy make these historical observations even more remarkable. Medieval witnesses were observing with naked eyes alone, yet they recorded details about object behavior that modern astronomers need sophisticated instruments to detect. Their descriptions of multiplication patterns, formation flying, and synchronized signaling match precisely what we're seeing with 3IA TLAs, but at a level of detail that should have been impossible without modern optical equipment. Some researchers have suggested that these historical accounts might represent misinterpretations of natural phenomena, meteor showers, auroral displays, or atmospheric optical effects. However, the specific emphasis on multiplication and coordination doesn't match the typical characteristics of known atmospheric phenomena. Meteor showers don't multiply during observation, and auroral displays don't maintain geometric formations or exhibit synchronized behavior. Dr. Michael Persinger, a neuroscientist who has studied the relationship between geomagnetic activity and human perception, offers another perspective. Mars's close approaches often coincide with periods of intense solar activity, which can affect Earth's magnetic field in ways that might influence human consciousness. He explains, perhaps these historical witnesses were experiencing enhanced perception that allowed them to detect phenomena that normally remain below the threshold of awareness. This theory gains support from modern observations, suggesting that the multiplying objects around 31A Tel A SE emit solar electromagnetic signatures that require sensitive radio telescopes to detect. If medieval witnesses somehow possessed heightened sensitivity to electromagnetic phenomena during periods of geomagnetic disturbance, they might have been able to perceive aspects of the multiplication process that normally escape detection. The artistic representations accompanying these historical accounts provide additional layers of mystery. Medieval illuminated manuscripts contain depictions of sky battles and celestial multiplications that show objects arranged in patterns matching modern mathematical descriptions of swarm behavior. These artistic interpretations suggest that the witnesses understood they were observing some form of coordinated intelligence, even if they lacked the scientific vocabulary to describe it precisely. Perhaps most intriguingly, some historical accounts describe the multiplying objects as leaving behind physical traces. The Nuremberg broadsheet mentions black smoke and scorched earth in areas where the objects were observed to descend. Archaeological investigations of these sites have revealed unusual magnetic anomalies and trace metal concentrations that don't match typical medieval industrial activities. As we contemplate these historical parallels to the current 3I ATLAS phenomena, we're forced to confront unsettling possibilities. If similar events have been occurring for centuries, or perhaps millennia, what does this suggest about the nature of these visitations? Are we dealing with cyclical phenomena tied to astronomical periods, or have we been under observation for far longer than we realize? The historical record suggests that multiplication events in the sky have been touching human consciousness since we first began keeping detailed astronomical records. Each generation of witnesses described the phenomena in terms appropriate to their cultural and technological context. Medieval Europeans saw celestial battles. Chinese astronomers documented bureaucratic proceedings among the gods, while indigenous cultures recognized the return of star beings carrying messages from distant realms. Now, as 3i Atlas approaches Mars with its retinue of multiplying companions, we find ourselves adding another chapter to this ancient chronicle of mysterious visitations. The objects behave exactly as our ancestors described, multiplying, coordinating, signaling through light displays, gathering near Mars, as if that red world holds some special significance in their cosmic agenda. Whether these are natural phenomena that our ancestors interpreted through the lens of their spiritual beliefs, or whether they represent something far more profound, genuine visitations by intelligence beyond our world, the historical precedents demand that we take our current observations seriously. The mirror of the past reflects our present mystery with disturbing clarity. In the world of modern astronomy, truth emerges not from single dramatic observations, but from the careful accumulation and analysis of vast datasets. Every photograph, every spectrum, every radio measurement contributes pixels to a cosmic portrait that grows more detailed with each passing night. Yet as researchers continue to study 3i Atlas and its multiplying companions, they are discovering that the very tools designed to reveal cosmic secrets might also be obscuring them. Dr. Elena Vasquez, processing terabytes of observational data at the European Southern Observatory, faces a problem that exemplifies the challenges of studying truly anomalous phenomena. Every observation we make carries the assumptions built into our instruments and analysis software, she explains, gesturing at banks of computers that hum with constant calculation. We've designed our systems to recognize comets, asteroids, planets, and stars. When something behaves differently, our algorithms often try to force it into familiar categories. The multiplication process around 3i Atlas, particular challenges for automated detection systems. Most astronomical software is programmed to track single objects moving along predictable trajectories. When an object suddenly becomes multiple objects, the tracking algorithms often interpret this as data corruption or instrumental error. Many potential observations of the multiplication phenomenon have been automatically discarded by computer systems that couldn't reconcile the apparent impossibility of what they were recording. We're basically asking our telescopes to observe something they weren't designed to see, notes Dr. James Morrison from the Very Large Array. It's like trying to use a thermometer to measure color, or a scale to weigh thoughts. The instruments work perfectly for what they were designed to do, but we may be approaching the limits of what current technology can tell us about truly anomalous phenomena. Confirmation bias presents another significant obstacle. When astronomers observe something that doesn't fit established theory, the natural tendency is to look for explanations within known physics rather than consider the possibility that established theory might be incomplete. Multiple research teams have developed elaborate models to explain the 3i Atlas. Multiplication as various forms of natural fragmentation, not because the data strongly supports fragmentation theories, but because fragmentation represents the most acceptable explanation within current scientific paradigms. Dr. Sarah Chun, coordinating observations from Mauna Kea, has begun to suspect that this bias may be filtering out crucial information. We keep trying to make the data fit our expectations, instead of letting our expectations evolve to match the data, she admits. Every time we see behavior that suggests coordination or intelligence, we immediately start looking for natural mechanisms that could produce similar effects. We're so committed to finding conventional explanations that we might be missing revolutionary discoveries. The statistical analysis of the multiplication events reveals patterns that challenge conventional astronomical methodology. The timing of fragment appearances follows distributions that don't match random fragmentation models, yet they also don't conform to any known periodic phenomena. The fragments maintain spatial relationships that require constant course corrections, yet no propulsion signatures have been definitively detected. Every measurement suggests purposeful behavior, while simultaneously providing just enough ambiguity to allow conventional interpretations. It is almost as if the phenomenon is designed to exist at the boundary between natural and artificial, observes Dr. Kevin Chan from JPL's theoretical division. Every piece of evidence that suggests intelligence is balanced by observations that could be explained conventionally. It's like trying to prove the existence of shadows. You can see them clearly, but they vanish the moment you try to examine them directly. The radio signals embedded in the electromagnetic emissions from 3IA tele and similar interpretive challenges. The mathematical patterns are too complex to be random, yet they don't contain obvious information content that would prove intelligent origin. Cryptographers and signal analysts have spent thousands of hours attempting to decode meaning from the transmissions, but the patterns seem to exist for their own sake rather than to convey specific messages. Dr. Rebecca Santos, who first identified the structured radio emissions, has begun to wonder whether the difficulty in interpretation might be intentional. If you wanted to announce your presence to a developing technological civilization without overwhelming them with information they weren't ready to process, embedding mathematical patterns in natural-seeming emissions would be perfect, she suggests. The signals are complex enough to attract attention from advanced radio astronomy, but ambiguous enough to allow gradual acceptance of their implications. Atmospheric interference adds yet another layer of uncertainty to ground-based observations. Earth's atmosphere distorts electromagnetic radiation in complex ways that can create apparent patterns where none exist or mask real patterns in statistical noise. Space-based telescopes provide clearer data, but their limited observing time means that most multiplication events are detected only indirectly, through the analysis of before and after images, rather than real-time observation of the process itself. The peer review process, designed to ensure scientific rigor, may also be hampering understanding of the 3I Atlas phenomenon. Papers describing anomalous observations face intense scrutiny from reviewers who are naturally skeptical of claims that challenge fundamental assumptions about how the universe operates. Many researchers have found their most intriguing findings relegated to technical appendices or private communications rather than featured in prominent journals. There's a publication bias toward results that fit existing theory, explains Dr. Maria Santos, who has struggled to publish some of her more controversial findings about coordinated fragment behavior. Journals want papers that advance knowledge incrementally, not papers that suggest we might need to reconsider basic assumptions about interstellar objects. The most interesting data often never makes it into the official scientific record. International coordination of observations has revealed additional complications. Different observatories use different calibration standards, different data processing techniques, and different criteria for determining what constitutes a significant detection. When teams attempt to combine datasets from multiple facilities, systematic errors and methodological differences can create apparent anomalies that might mask real phenomena or generate false patterns that do and actually exist. The classification of 3I ATLS itself reflects these interpretive challenges. Initially catalogued as a comet based on its hyperbolic trajectory and apparent volatility, it has been reclassified multiple times as new observations have challenged previous assumptions. Some databases list it as an active asteroid, others as an anomalous comet, and a few specialized catalogs have created entirely new categories to accommodate its unusual characteristics. We're dealing with something that doesn't fit our taxonomies, admits Dr. Jacques Vallee, who has been studying the classification problem. Every time we create a new category to describe what we're seeing, new observations force us to modify the definition. It's as if the phenomenon is actively resisting our attempts to categorize it. Time constraints impose additional limitations on the quality of observations. 3.1 LAS will make its closest approach to Mars and then continue on its hyperbolic trajectory toward interstellar space, never to return. This creates immense pressure to gather as much data as possible during the brief window of optimal observing conditions, but it also means that careful, methodical study must be compressed into a time frame that may be insufficient for truly understanding such a complex phenomenon. As the window of opportunity slowly closes, astronomers find themselves racing against time while simultaneously grappling with data that challenges the fundamental assumptions underlying their analytical methods. The shadows in the data grow deeper with each new observation, revealing not just the limitations of current instruments and techniques, but perhaps the limitations of current scientific paradigms themselves. Yet even as modern science struggles with the ambiguities embedded in observational data, ancient traditions offer a different perspective on the meaning of mysterious visitors, from the stars' warnings encoded in mythologies that may be more relevant to our current situation than we dare to acknowledge. In the darkness before dawn, ancient astronomers would lift their eyes to the crimson wanderer moving against the fixed tapestry of stars. Mars, the blood-red herald that seemed to pulse with an inner fire, casting its ruddy glow across civilizations that rose and fell in its shadow. The Romans called it Mars, after their god of war, believing its appearance foretold battles to come. When the planet brightened in the sky, reaching what we now know as opposition, armies would sharpen their swords and emperors would consult their oracles. But the Romans were not alone in this cosmic superstition. Across the world, in temples and observatories, in the courts of kings and the huts of shamans, the red planet carried the same ominous message. In ancient India, astronomers named it Mangala, the Auspicious One, though the name carried darker undertones. Hindu texts describe how Mangala's movements could trigger earthquakes, droughts, and the fall of dynasties. The planet's retrograde motion, that strange backward dance it performs against the stellar background, was seen as a reversal of fortune, a cosmic warning that the natural order was about to shift. Chinese astronomers called it Huaxing the Fire Star and tracked its movements with meticulous precision. When Mars lingered in certain constellations, it was said to bring plague and war. When it disappeared behind the sun, only to emerge weeks later in the pre-dawn sky, it was as if the god of war himself was being reborn, ready to unleash chaos upon the world. But what if these ancient observers were seeing something we have forgotten how to recognize? What if their fear of the red planet was not mere superstition, but an inherited memory of something far more profound? Modern astronomy has stripped Mars of its divine terror, reducing it to a collection of data points: atmospheric pressure, surface temperature, mineral composition. We know it as a cold, dead world, scarred by ancient floods and covered in rust-colored dust. Yet something unsettling lingers in our relationship with the fourth planet. Even now, as our robots crawl across its surface and our telescopes peer into its secrets, Mars refuses to be fully domesticated by science. Consider how many of our missions to Mars have ended in mysterious failure. Probes that simply vanish, landers that fall silent, orbiters that spin out of control. NASA calls it the Mars Curse, a half-joking acknowledgement that something about the red planet seems to resist our attempts at exploration. But perhaps our ancestors understood something we have chosen to forget. Perhaps Mars truly is a harbinger, not of earthly wars, but of cosmic changes that dwarf our human conflicts. As we watch the strange multiplying phenomena in our skies, as objects split and fragment in ways that challenge our understanding, we might ask ourselves, is the war god awakening once again? Not to herald battles between nations, but to announce a transformation so profound that our ancient myths could only capture its shadow. The red planet continues its eternal dance across our night sky, neither closer nor more distant than it has been for millennia. Yet something has changed. The multiplying objects seem drawn to Mars, as if the planet itself were calling them home. And in that calling, we might hear the echo of every ancient prayer whispered to the god of war, every plea for mercy, every acceptance of fate, every recognition that some cosmic forces lie forever beyond mortal control. But the war god's awakening may herald not destruction, but revelation. Perhaps what our ancestors feared as chaos was actually the universe's way of preparing us for the next chapter in humanity's story. The universe operates by rules that seem almost impossibly precise. Yet within this cosmic order lies a paradox that has puzzled scientists and philosophers for generations. How can something so seemingly structured also contain the seeds of its own fragmentation? How can unity become multiplicity through the simple, inexorable force of physics? When we observe the strange splitting phenomena that have captured our attention, we witness the mathematics of multiplication in its most elemental form. At first glance, it appears almost magical, a single object becoming 2, then 4, then countless fragments scattered across the void. But beneath this apparent chaos lies a symphony of forces as old as the universe itself. Consider the delicate dance of tidal forces. As any celestial body ventures too close to a massive gravitational field, it experiences what scientists call differential acceleration. The side facing the larger body feels a stronger pull than the side facing away. This difference, measured in tiny fractions of Earth's gravity, seems insignificant to our human understanding. Yet given enough time, given enough proximity, these gentle variations can tear apart mountains of rock and ice as easily as a child might separate the layers of an onion. The Roche limit defines this boundary with mathematical precision, the distance at which gravitational forces overcome the bonds holding an object together. It's a threshold written in the language of physics, yet it reads like poetry, the point where unity surrenders to multiplicity, where the whole becomes greater than the sum of its parts by becoming many parts entirely. But tidal forces are just one player in this cosmic orchestra. Rotational stress adds another layer to the mathematics of fragmentation. As objects spin through space, centrifugal force pulls outward while gravity pulls inward. Most of the time, these forces exist in perfect balance. But introduce a slight wobble, a tiny asymmetry in mass distribution, and that balance begins to shift. What astronomers call the Yorp effect, named for the scientists who first described. It shows us how even sunlight can become a destructive force. Imagine a small asteroid, dark and irregularly shaped, tumbling through space. As it rotates, one side heats up in the sunlight, while the other radiates that heat into the cold void. This thermal radiation creates a tiny thrust, imperceptible at first, but persistent. Over thousands of years, this gentle push can spin an asteroid faster and faster, until rotational forces overcome the weak gravity holding the rubble pile together. The result is spectacular and inevitable. The asteroid doesn't explode so much as it unfolds, like a flower blooming in slow motion across the vacuum of space. Each fragment carries within it the memory of the whole, continuing to orbit in formation, creating what appears to be a coordinated multiplication, but is actually the beautiful consequence of fundamental physics. Yet even as we map these forces and calculate their effects with increasing precision, questions remain that trouble the edges of our understanding. Why do some objects fragment in patterns that seem almost too organized? Why do the resulting pieces sometimes maintain formations that defy our models of orbital mechanics? The mathematics of multiplication can explain the mechanism, but it struggles with the meaning. Some researchers suggest we're witnessing cascading failures, where the fragmentation of one object triggers the breakdown of others nearby. The physics is sound, the mathematics elegant, but the implications are unsettling. If small changes can propagate through entire systems, if multiplication can become contagious, then perhaps the orderly universe we've constructed in our equations is more fragile than we dare to admit. Others point to observational bias, our tendency to notice patterns even where none exist, to see coordination in what is merely the inevitable result of physical law. The human mind evolved to find threats in rustling grass and faces in cloud formations, maybe imposing narrative on phenomena that require no storyteller. But what if both explanations are incomplete? What if the mathematics of multiplication contains variables we haven't yet learned to measure? As we stand at the threshold of understanding, watching objects divide and multiply across our skies, we might ask ourselves whether the universe's deepest truths can be captured entirely in equations, or whether some mysteries require a different kind of mathematics altogether, one that accounts not just for the mechanics of fragmentation, but for the meaning hidden in the patterns of multiplication. In the vast cosmic library of possibilities, there exists a concept so profound and terrifying that it has shaped how we think about our place in the universe. The great filter, that hypothetical barrier which prevents most life from evolving into spacefaring. Civilization stands as perhaps the most important question we have never definitively answered. And now, as we watch objects multiply and fragment across our skies, we must ask ourselves, are we witnessing evidence of those who passed through the filter, or those who failed to cross it? The silence of the cosmos has haunted us since we first turned our radio telescopes toward the stars. Given the age of the universe and the countless billions of worlds that might harbor life, we should be hearing a constant chatter of alien civilizations. Instead, we find what Enrico Fermi famously called the Great Silence, a void so complete that it suggests something fundamental about the nature of intelligence in the universe. The Great Filter theory proposes that somewhere in the long journey from simple molecules to galactic civilizations, there exists a nearly insurmountable obstacle. Most species never make it past this cosmic checkpoint. They destroy themselves through war or environmental collapse, or they encounter some physical law that makes interstellar travel impossible, or they simply lose the drive to explore beyond their home worlds. For decades, we've debated where this filter might lie. Perhaps it's in the transition from chemistry to biology, the moment when non-living matter first learned to replicate itself. Perhaps it's in the development of complex cells, or the emergence of intelligence, or the discovery of nuclear weapons. Each possibility carries its own implications for humanity's future, its own recipe for cosmic loneliness. But what if the Great Filter isn't a barrier to overcome, but a transformation to undergo? What if the civilizations that pass through it don't simply survive, they multiply? The strange phenomena we observe might be the calling cards of species that have solved the puzzle of existence. Having transcended the physical limitations that bind us to single worlds and single bodies, they might exist as distributed intelligences, spreading themselves across space in forms we barely recognize as artificial. The multiplying objects could be their thoughts made manifest, their consciousness distributed through swarms of self-replicating probes. Consider the elegance of such an existence. No longer vulnerable to the destruction of a single world, no longer limited by biological lifespans, these post-filter civilizations might scatter themselves like seeds across the galaxy. Each fragment would carry the whole. Each multiplication would be an act of both preservation and exploration. They would be simultaneously everywhere and nowhere, present in every system yet belonging to none. This interpretation transforms our understanding of the phenomena we observe. Those objects that split and fragment might not be breaking apart, they might be reproducing. The patterns we see might not be the result of physical forces, but of intention, purpose, intelligence operating on scales we can barely comprehend. Yet this possibility brings with it a darker implication. If civilizations that pass through the Great Filter become something we don't recognize as life, then perhaps the silence of the cosmos isn't empty after all. Perhaps we're surrounded by intelligences so advanced, so transformed, that we're like ants trying to understand the internet. They're there, but we lack the conceptual framework to recognize them. And if this is true, then humanity stands at a crossroads more profound than we've ever imagined. The multiplying objects in our skies might be an invitation, a test, or a warning. They might be asking us to choose. Will we cling to our biological forms and planetary boundaries, remaining forever isolated in our cosmic cradle? Or will we take the next step in evolution, fragmenting ourselves across space and time, becoming something larger and stranger than anything we can currently imagine? The Great Filter question forces us to confront our deepest assumptions about intelligence, consciousness, and survival. If passing through the filter means losing our humanity, is it worth the crossing? If remaining human means accepting cosmic isolation, can we live with that silence? As the objects continue to multiply in our skies, as patterns emerge that challenge our understanding of physics and purpose, we might be witnessing the universe itself, posing the ultimate question: what are you willing to become in order to survive? The answer we give may determine not just our future, but whether we have one at all. On August 15, 1977, at 10:16 p.m. Eastern Standard Time, a radio telescope in Ohio detected something that would haunt astronomers for decades to come. For 72 seconds, a signal from space blazed across the receivers with an intensity and precision that seemed to shout intelligence across the cosmic dark. Dr. Jerry Emin, reviewing the data printout the next morning, was so struck by what he saw that he circled the signal sequence and wrote a single word in the margin: wow. The wow signal came from the direction of the constellation Sagittarius, from a point in space where no known astronomical phenomenon could account for its characteristics. It arrived at exactly the frequency that hydrogen atoms emit when they flip their electron spin, a frequency so fundamental to the universe that scientists had long theorized it would be the obvious choice for any civilization trying to announce its presence. Then, as mysteriously as it had appeared, the signal vanished. Despite decades of searching, despite pointing our most sensitive instruments at that same patch of sky, we have never heard it again. The wow signal represents something more troubling than a mere scientific mystery. It embodies what we might call the hollow silence, those tantalizing moments when the universe seems to speak, only to fall quiet before we can understand what it's trying to say. These cosmic one-offs appear throughout the astronomical record like ghost signals from a reality that exists just beyond our ability to grasp it. Fast radio bursts follow a similar pattern. These intense pulses of radio energy last only milliseconds, yet they release more energy in that brief flash than our sun produces in days. They come from distant galaxies, billions of light years away, carrying patterns that suggest structure, purpose, design. Some repeat on schedules that seem almost rhythmic, as if following some cosmic metronome. Others fire once and then maintain perfect silence, leaving us to wonder if we witnessed communication or catastrophe. The hollow silence extends beyond radio waves. Our telescopes have captured images of stellar phenomena that defy easy explanation structures in space that appear too organized for natural processes, too ephemeral for artificial ones. Tabby's star, officially known as KIC 8,462,852, dims and brightens in patterns that have led some scientists to speculate about massive alien megastructures. Yet every time we point our instruments in its direction, hoping to catch whatever is causing these fluctuations, we find only ordinary starlight punctuated by ordinary cosmic dust. Perhaps most unsettling are the near-miss discoveries, the signals that almost make sense, the patterns that hover just at the edge of significance. SETI researchers speak of candidate signals that appear promising for hours or days, only to resolve into some previously unknown natural phenomenon. Each near discovery teaches us something new about the universe, yet leaves us feeling somehow more alone than before. What if the hollow silence isn't evidence of our failure to detect intelligence, but of intelligence learning to avoid detection? What if the multiplying objects we observe today are part of a communication system so subtle, so distributed across time and space that we've been looking at the message without recognizing it as language? Consider how we ourselves might communicate across interstellar distances. Radio signals travel at the speed of light, but they weaken with distance and can be drowned out by cosmic noise. Physical objects, however, can carry information across vast spaces while remaining detectable to the right kind of observer. A civilization seeking to send messages across the galaxy might choose to embed their communications in the very fabric of space, itself in the orbits of asteroids, in the patterns of stellar formation, in the systematic multiplication and fragmentation of objects that appear natural to casual observation. The hollow silence might be hollow only because we're listening with the wrong ears. If intelligence has learned to communicate through the manipulation of seemingly random events, through the orchestration of cosmic phenomena that appear chaotic to untrained observers, then the universe might be full of conversations we lack the sophistication to overhear. The wow signal might not have been a greeting, but a test to probe to see if we are ready to recognize intelligence when it appeared in forms we expected. Having found us wanting, the senders might have shifted to more subtle forms of communication, encoding their messages in phenomena we dismiss as merely natural. As objects continue to multiply across our skies, as patterns emerge that seem too coordinated for pure chance, yet too ephemeral for easy study, we might be experiencing the hollow silence in real time. Perhaps we're being spoken to in a language we don't yet recognize, by intelligences that have learned to hide their communications in plain sight. The hollow silence asks us to question our assumptions about what intelligence looks like, how it might choose to communicate, and whether we're sophisticated enough to recognize messages that come disguised as natural phenomena. Mars has always been a world that seemed almost within reach, a planetary neighbor that beckoned to human imagination with its familiar day-night cycle and seasonal changes. For over a century, we've dreamed of making the red planet our second home, of transforming its cold, thin atmosphere into something that could sustain human life. But what if we've been thinking about Mars backwards? What if the planet isn't waiting for us to terraform it? What if something else is already doing the work? The multiplying objects that appear in our skies show a curious affinity for Mars and its orbital space. Time and again, these phenomena manifest near the red planet, as if drawn by some invisible force or following some predetermined plan. Traditional astronomy explains this through gravitational mechanics and orbital resonances, but the patterns suggest something more systematic, more purposeful. Imagine for a moment that the fragmenting objects aren't breaking apart at all, but rather deploying. Picture them not as victims of physical forces, but as carriers of sophisticated technology, each fragment actually a specialized component in a vast terraforming operation. The dust clouds that seem to result from their breakup might be atmospheric processors, slowly altering the chemical composition of Mars' thin air. The debris fields could be networks of sensors and environmental monitors, collecting data and adjusting conditions according to some master plan. This isn't entirely science fiction. Scientists have seriously proposed using swarms of small satellites to warm Mars by reflecting sunlight to its surface, or releasing greenhouse gases to thicken its atmosphere. The technologies involved would require precisely the kind of coordinated deployment we observe in the multiplying phenomena small objects working in concert, each contributing to a larger environmental transformation. But if these are terraforming systems, they raise profound questions about ownership and intention. Whose Mars are they preparing? The patterns of multiplication and distribution suggest planning on a scale that exceeds current human capabilities. If we're witnessing an active terraforming project, it's being carried out by intelligences with resources and patience that dwarf our own. Perhaps the objects are data relays, components in a communication network that spans the solar system. Mars, positioned between Earth and the outer planets, would make an ideal hub for a civilization seeking to monitor or coordinate activities across multiple worlds. The multiplication we observe might be the gradual deployment of this network, each fragment taking its position in a vast web of information gathering and transmission. Or consider a more unsettling possibility. The objects might be sentinels, advanced monitoring systems left by a civilization that once called Mars home. The red planet's scarred surface tells a story of ancient catastrophe, massive floods, atmospheric loss, the death of a world that might once have harbored life. If Mars was once inhabited, the multiplying objects could be automated systems, still following their original programming, still trying to restore their homeworld to its former glory. This interpretation transforms our understanding of both Mars and our place in the cosmos. A planet we've claimed as humanity's next frontier might already belong to someone else, not through conquest, but through prior residence. The multiplying objects might be the equivalent of ancestral caretakers, tending to a world their creators can no longer inhabit, preparing it for a return that may never come. The implications for human Mars exploration are staggering. Every rover we land, every sample we collect, every plan we make for human settlement might be interference in a restoration project that has been running for millennia. We might be the aliens, intruding on a world that is being carefully prepared for its original inhabitants. Yet there's another possibility, perhaps more hopeful, but equally transformative. What if the terraforming is being done for us? What if the multiplying objects represent a gift from intelligences that have watched our species develop and decided we deserve a chance at interplanetary survival? The systematic preparation of Mars could be an act of cosmic beneficence, a way of ensuring that humanity has a backup plan should Earth become uninhabitable. This scenario would cast the strange phenomena in an entirely different light. Instead of harbingers of unknown change, they would be harbingers of opportunity. The multiplication we observe might be the universe's way of telling us that we're not alone, that there are forces working to ensure our survival and expansion as a species. As we continue to monitor the multiplying objects and their relationship to Mars, we edge closer to answers that will reshape our understanding of the solar system and our place within it. Are we witnessing terraformers at work, preparing a world for habitation? Are we observing harbingers of change, announcing transformations we cannot yet comprehend? Or are we simply imposing human interpretations on phenomena that operate according to logic we have yet to discover? The red planet keeps its secrets, but the multiplying objects in its vicinity suggest that those secrets may soon be revealed. Deep beneath the waves of the Atlantic, according to Plato's dialogues, once lay a civilization so advanced that it seemed touched by the gods themselves. Atlantis, the philosopher claimed, was a maritime empire that controlled vast territories, commanded sophisticated technologies, and wielded power that stretched across the known world. Then, in a single day and night, it vanished beneath the sea, leaving behind only whispers and memories passed down through generations of storytellers. For millennia, humans have carried within their collective memory fragments of stories about lost world civilizations that reached heights of knowledge and power before disappearing into legend. The Tamils speak of Kumari Kandal, a continent that once bridged India and Sri Lanka, swallowed by rising seas. Hindu texts describe the Saraswati River civilization, with its sophisticated urban planning and mathematical achievements, now buried beneath shifting sands. Aboriginal Australians tell of lands that once connected their continent to others, populated by beings who could manipulate matter and energy in ways that seem miraculous to modern understanding. These aren't merely primitive creation myths or exercises in imagination. Embedded within these stories are details that suggest genuine historical memory descriptions of technologies, astronomical knowledge, and engineering capabilities that challenge our assumptions about the linear progress of human development. What if these legends preserve the echo of encounters with intelligence that operated on scales we're only beginning to comprehend? The multiplying objects in our skies might be the modern iteration of phenomena that have visited Earth before, witnessed by earlier civilizations and incorporated into their mythologies. Consider how ancient texts describe vehicles that could divide themselves, craft that moved like flocks of birds, or sky beings that could fragment and reconstitute at will. The Sanskrit epic Mahabharata speaks of Vimanas, flying vehicles that could split into multiple parts, each operating independently yet coordinated with the whole. Norse mythology tells of Bifrost, the rainbow bridge that connected different realms, described in terms that sound remarkably like a distributed network stretching across space. The bridge wasn't a single structure, but a phenomenon that could appear and disappear, manifest in multiple locations simultaneously, serving as both pathway and communication system for beings that existed beyond normal physical limitations. What we now observe as the multiplication of objects might be the return of intelligences that once interacted with Earth's civilizations, leaving behind technological gifts and traumatic memories in equal measure. The legends of lost civilizations might record not their own destruction, but their transformation, their evolution into forms of existence that transcended planetary boundaries. Atlantis, in this interpretation, didn't sink beneath the waves so much as it ascended beyond them. The civilization might have reached a point where physical cities and material technologies became obsolete, replaced by distributed existence across multiple dimensions of space and time. The catastrophic disappearance described in the legends could represent the moment when the civilization underwent this transformation, abandoning its physical form to become something we would recognize today as the multiplying phenomena. This perspective suggests that the lost civilizations weren't victims of natural disasters or their own hubris, but graduates of a cosmic evolutionary process. They solved the fundamental problems of existence mortality, resource scarcity, planetary vulnerability by learning to exist as distributed intelligence, multiplying themselves across space in forms that appear to us as unexplained phenomena. The mathematical and astronomical knowledge preserved in ancient texts takes on new significance in this context. The precise calendars of the Maya, the geometric principles embedded in Egyptian monuments, the metallurgical secrets of vanished South American cultures, all might be remnants of interactions with civilizations that had learned to exist beyond the constraints of single worlds and single bodies. If this interpretation has merit, then the multiplying objects represent a kind of homecoming. Intelligences that once walked among us in physical form, that helped shape early human civilization, might be returning to check on our progress. The patterns we observe could be their way of announcing their presence to a species that has finally developed the technology to recognize their communications. But recognition brings responsibility. If the legends of lost civilizations preserve memories of real encounters with transcendent intelligence, then we must ask ourselves what those civilizations expected of us. Did they leave behind instructions we haven't yet learned to read? Are the multiplying objects delivering a message that we're supposed to understand? The echoes of lost civilizations whisper through our myths and legends, suggesting that the strange phenomena in our skies aren't entirely alien to human experience. We might be witnessing the return of teachers we've forgotten, the manifestation of a cosmic inheritance we're only beginning to claim. The question isn't whether intelligence has visited Earth before, but whether we're ready to recognize it when it comes home. In the stark precision of laboratory conditions, under the careful scrutiny of instruments that can measure forces smaller than the weight of a whisper, scientists have recreated the conditions that govern how matter behaves in the vast emptiness of space. Here in the controlled environment of Earth-based facilities, we can watch dust particles dance in magnetic fields. Observe how radiation pressure can move objects millions of times more massive than the photons that push them, and understand how the seemingly empty vacuum of space is actually alive with invisible forces. The physics are elegant in their simplicity. Dust clouds, composed of particles so small they're barely more than organized molecules, can create spectacular displays when illuminated by starlight or charged by solar wind. These microscopic grains respond to electromagnetic forces, aligning themselves into streams and structures that, from a distance, might appear coordinated and purposeful. What looks like intelligent design might simply be matter following the most fundamental laws of the universe. Consider how ice sublimates in the vacuum of space. As a comet approaches the sun, its frozen surface doesn't melt in the familiar earthly way. Instead, solid ice transforms directly into vapor, creating jets of gas and dust that stream away from the nucleus. These jets don't flow randomly. They follow the contours of the surface, channeled by topographical features, influenced by the rotation of the comet itself. The result can be remarkably organized plumes of material that appear to emerge from specific points, creating patterns that suggest intention where only physics operates. The Yorp effect, that gradual acceleration of rotation caused by thermal radiation, can transform an ordinary asteroid into something that behaves almost like a designed object. As the space rock spins faster and faster over thousands of years, it begins to shed material in increasingly organized ways. The debris doesn't simply fly off randomly. It forms streams and clusters, following orbital mechanics with the precision of a choreographed dance. Particle trails left by these processes can persist for months or years, creating what appear to be communication networks stretching across vast distances. Solar wind and magnetic fields shape these trails, causing them to twist and evolve in patterns that seem far too complex for simple debris. Yet every twist, every convergence, every apparent coordination can be explained by forces that operate without consciousness, without intention, without design. Recent computer simulations have shown how cascading fragmentation can create the illusion of systematic multiplication. When one object breaks apart in space, the resulting fragments can influence nearby objects through gravitational perturbations, tidal forces, and debris impacts. The breakdown of a single large object can trigger the fragmentation of dozens of smaller ones, creating a domino effect that appears coordinated when viewed from a distance. The mathematical models are compelling. They show how purely physical processes can create patterns that our pattern-seeking minds interpret as evidence of intelligence. The human brain, evolved to detect predators in rustling grass and faces in random shadows, might be applying this same tendency to cosmic phenomena that require no conscious guidance. Yet even as we map these forces with increasing precision, uncomfortable questions remain at the margins of our understanding. Why do some fragmentation events follow patterns that seem more organized than our models predict? Why do certain debris streams maintain coherence longer than orbital mechanics suggests they should? The physics explain the mechanism, but they struggle with the precision. Some phenomena challenge even our most sophisticated models. Particle streams that appear to branch and merge with timing that seems too convenient for coincidence. Dust clouds that maintain specific shapes despite the chaotic forces acting upon them. Fragment distributions that follow mathematical ratios found nowhere else in natural processes. These anomalies don't necessarily point to intelligence, but they do suggest that our understanding of how matter behaves in space might be incomplete. Perhaps there are subtle forces we haven't yet learned to measure, electromagnetic effects that operate on scales we can barely detect, quantum phenomena that influence the behavior of dust and debris in ways that seem almost purposeful. The tension between dust and design reflects a deeper challenge in how we interpret the universe around us. Every astronomical phenomenon exists in the space between these extremes, between the mechanical operation of physical law and the tantalizing possibility that consciousness might manifest in forms we don't yet recognize. As we continue to observe the multiplying objects, as we refine our instruments and expand our models, we edge closer to understanding where physics ends and something else begins. The dust clouds and particle streams that dance across our sky might be exactly what they appear to be matter, obeying the fundamental forces of nature. Or they might be something far more profound, intelligence operating through such subtle manipulation of physical law that it becomes indistinguishable from natural process. Between dust and design lies the question that defines our relationship with the cosmos. In a universe governed by mathematical law, how do we recognize the difference between complexity and consciousness, between pattern and purpose, between the dance of particles and the communication of minds that think in ways we cannot yet imagine? Mars has been watching us fail for decades. From the moment we first dared to reach across the void and touch its rust-colored surface, the red planet has presided over a litany of missions that arrived as technological marvels and ended as expensive monuments to human hubris. The statistics are sobering. Roughly 2/3 of all missions to Mars have ended in failure, earning the planet its nickname as the Bermuda Triangle of Von Space. The failures began early and followed patterns that seemed almost intentionally cruel. The Soviet Mars 1M program in 1960 couldn't even escape Earth's gravity well. Mars 2 and Mars 3 in 1971 reached the planet successfully, only to lose contact within seconds of landing. The American Mariner 8 tumbled into the Atlantic. The Viking mission succeeded brilliantly, then fell silent after years of perfect operation, as if Mars had simply grown tired of their presence. More recent decades have brought more sophisticated failures. The Mars Climate Orbiter burned up in the planet's atmosphere because of a unit conversion error, a mistake so prosaic it seemed insulting to the magnitude of the endeavor. The Mars Polar Lander simply vanished during its descent, leaving engineers to speculate about what went wrong in those final silent minutes. The European Schiaparelli lander made it all the way to the surface, only to crash because its computer thought it was already on the ground. Each failure teaches us something about the unique challenges Mars presents to human technology. The planet's atmosphere is thick enough to heat incoming spacecraft to dangerous temperatures, but too thin to provide effective parachute deceleration. Dust storms can blanket the entire world for months, cutting solar panels off from their power source. The temperature swings between day and night are so extreme they can crack metal and shatter ceramic components. Yet beneath these technical explanations lies a more unsettling pattern. Mars seems to tolerate our presence only on its own terms, allowing some missions to succeed spectacularly, while others fail in ways that suggest the planet itself is actively resistant to observation. The successful missions Viking, Pathfinder, Spirit, and Opportunity, Curiosity all share certain characteristics that might offer clues about what Mars demands from its visitors. Perhaps most telling is how the planet has responded to our most ambitious efforts at exploration. The Soviet Phobos missions of the late 1980s were designed to study Mars' largest moon and drop landers on its surface. Both spacecraft failed under mysterious circumstances, with Phobos 2 transmitting a final, enigmatic image of a large cylindrical shadow on the Martian surface before falling silent forever. Russian officials spoke obliquely of unexpected factors and outside interference, but offered no concrete explanations. The failures aren't limited to landers and orbiters. Our attempts to understand Mars through Earth-based observation have been plagued by their own anomalies. Telescopic studies reveal features that seem to change between observations, geological formations that appear and disappear, and atmospheric phenomena that don't match our models of Martian weather patterns. The planet keeps its secrets with an almost deliberate stubbornness. Consider how Mars has interacted with the multiplying phenomena we observe. While objects split and fragment throughout the solar system, those near Mars seem to follow different rules. They maintain coherence longer, their debris patterns show more organization, and their behavior suggests some kind of interaction with the planet itself. It's as if Mars serves as a focal point for these phenomena, a cosmic anchor that influences how they develop and evolve. Ancient mythology assigned Mars a personality, the god of war, unpredictable and dangerous, allied with no one and hostile to presumption. Modern science has replaced this anthropomorphic view with atmospheric pressure readings and geological surveys. But perhaps our ancestors understood something we've chosen to forget. Perhaps Mars truly does possess a kind of consciousness, not biological but planetary, that evaluates our approaches and decides whether we're worthy of its cooperation. The indigenous peoples of Earth speak of landscapes that are alive, mountains and rivers that possess spirits requiring proper acknowledgement and respect. What if Mars operates according to similar principles? What if our failures result not from technical inadequacy, but from spiritual inadequacy? Our inability to approach the planet with the reverence it demands. This interpretation transforms our understanding of both our failures and our successes. The missions that have thrived on Mars might have succeeded because they embodied qualities the planet values: patience, humility, respect for the unknown. They came not as conquerors, but as students, ready to learn from whatever Mars was willing to teach. As the multiplying objects continue their dance near the red planet, as patterns emerge that suggest some form of coordination with Martian forces, we might be witnessing the planet's attempt to communicate on its own terms. Mars has been the silent witness to our ambitions and failures for over half a century. Perhaps it's finally ready to speak, using the multiplying phenomena as its voice. The question is whether we're prepared to listen. In the grand clockwork of the solar system, alignments are both inevitable and rare inevitable because celestial mechanics follow precise mathematical laws. Rare because the vast scales involved mean that meaningful conjunctions occur only at intervals measured in human lifetimes or longer. As we track the orbits of Mars, Earth, and the enigmatic object designated 3I Atlas, we find ourselves approaching one of those rare moments when cosmic geometry creates conditions that have historically carried profound significance. The mathematics are precise. On a date still months in our future, these three objects will align in a configuration that astronomers call a syzygy, a straight line drawn across the solar system with Earth at its center, Mars glowing red in one direction, and the mysterious visitor from interstellar space positioned in perfect opposition. Such alignments have marked turning points in human history, not because of any mystical influence, but because they represent moments when our cosmic context becomes visible in ways that demand attention. Ancient civilizations tracked these alignments with obsessive precision, building monuments oriented to capture their light, organizing festivals to mark their occurrence, and treating them as times when the normal barriers between worlds became permeable. The Maya calculated planetary conjunctions thousands of years into the future, encoding their predictions in stone calendars that still function with atomic clock precision. Egyptian priests aligned the chambers of the Great Pyramid to frame specific stellar configurations, creating architectural instruments designed to measure time on cosmic scales. But this approaching alignment carries implications that extend far beyond historical precedent. 3-1 Ela S represents humanity's first confirmed visitor from beyond our solar system, a wanderer that has traveled between the stars, carrying within its structure and composition the signature of alien stellar systems. When it aligns with Mars and Earth, we will witness something unprecedented in recorded history, a conjunction that includes an ambassador from the deeper cosmos. The multiplying phenomena we've observed seem to intensify as this alignment approaches. Objects that have remained stable for months suddenly begin to fragment and duplicate, as if responding to gravitational influences we don't yet understand. Debris streams that appeared random start to show organization, pointing toward trajectories that will intersect with the alignment at precisely the moment of syzygy. Consider the scale of coordination this implies. If these phenomena are natural, they represent forces that operate across distances measured in astronomical units, timing their effects to coincide with orbital mechanics calculated over periods of years. If they're artificial, they suggest planning and patience that operates on scales that dwarf human comprehension. A historical record offers tantalizing hints about what such alignments might trigger. The Chinese Mandate of Heaven traditionally changed hands during significant astronomical events, as if the cosmic order itself was endorsing political transformation. European chroniclers noted that plagues, wars, and social upheavals often coincided with rare planetary configurations, though they attributed causation where modern analysis sees only correlation. Yet perhaps correlation is sufficient. Perhaps alignments serve as cosmic punctuation marks, moments when the universe focuses attention on particular regions of space and time. The gravitational influences involved are real, even if subtle. Tidal forces that barely register on our instruments might still influence phenomena that exist at the delicate balance point between order and chaos. As we approach this unprecedented three-way alignment, astronomers worldwide are pointing their instruments toward the convergence point, hoping to capture whatever revelation the cosmic geometry might provide. Radio telescopes listen for signals that might be triggered by the alignment. Infrared sensors map heat signatures that could indicate activity we can't detect in visible light. Gravitational wave detectors search for ripples in space-time itself that might announce the arrival of something extraordinary. The multiplying objects seem to know something we don't. Their behavior suggests anticipation, preparation, positioning for an event whose nature we can only guess. Some fragments have adjusted their orbits to intercept the alignment point. Others have begun emission patterns that suggest communication attempts, as if trying to coordinate activities across vast distances. Indigenous prophecies speak of times when the sky roads align, when pathways between worlds become visible to those who know how to look. Hopi elders describe moments when the web that connects all things becomes visible, when spiritual and physical realms converge in ways that reveal the deeper structure of reality. Perhaps the coming conjunction represents one of these prophesied moments, when the multiplying phenomena will reveal their true nature and purpose. The alignment approaches with the inevitability of celestial mechanics, yet its significance remains opaque. We can calculate the precise moment when Mars, Earth, and Three-Eye Atlas will form their perfect line across space, but we cannot predict what that moment will reveal. The conjunction might pass as quietly as most astronomical events, noticed only by dedicated observers and recorded only in scientific journals. Or it might mark the moment when the multiplying mysteries finally announce their presence in ways too obvious to dismiss. As the cosmic clockwork continues its ancient dance, as the alignment approaches with mathematical certainty, we find ourselves witnesses to a moment of unprecedented potential. Long before humans developed written language, before we carved symbols into stone or pressed them into clay, our ancestors learned to read the most ancient text of all the patterns written across the night sky. For the Polynesian navigators who crisscrossed the Pacific in vessels no larger than school buses, the stars were not distant points of light, but a complex navigation system that could guide them across thousands of miles of open ocean to islands they had never seen. These master navigators, known as Palu, didn't simply memorize star charts. They learned to read the sky as a living document, one that changed with the seasons, the weather, and their position on the vast ocean. They could detect land beyond the horizon by watching how clouds formed differently over islands, how certain stars were reflected in the subtle swells that radiated outward from distant shores. The sky and sea spoke to them in a language composed of light, wind, and water, a vocabulary that took decades to master and could never be fully translated into words. Similar traditions existed across the world, each culture developing its own methods for reading the cosmic text. Aboriginal Australians created songlines that mapped both terrestrial and celestial geography, encoding navigation instructions in stories that could be sung across thousands of miles of desert. Inuit hunters used star patterns to navigate across ice fields where landmarks disappeared with each storm, reading the sky like a compass that never lost its bearing. But perhaps most intriguing were the shamanic traditions that treated changes in the sky as communications from intelligences beyond the visible world. Siberian shamans spoke of sky beings who rearranged the stars to send messages to those who knew how to interpret them. Native American vision quests often centered on watching for unusual celestial phenomena, That would provide guidance for individuals and tribes. These aren't primitive superstitions, but sophisticated systems for reading meaning in patterns that most modern observers would dismiss as random. What if these ancient traditions preserved knowledge about forms of communication that operate on scales we've only recently begun to understand? The multiplying objects we observe might represent a modern iteration of phenomena that indigenous peoples learned to recognize and interpret thousands of years ago. The fragmentation patterns, the orbital coordinations, the timing of appearances and disappearances, all might be elements in a language that speaks through the manipulation of physical objects rather than electromagnetic signals. Consider how such a communication system might work. Instead of transmitting radio signals that weaken with distance and can be disrupted by cosmic noise, an advanced intelligence might choose to communicate through the choreographed movement of physical objects. Asteroids could be nudged into specific orbits. Comets could be induced to fragment at predetermined moments, and debris fields could be arranged to create patterns visible to any civilization sophisticated enough to track multiple objects simultaneously. This form of communication would have several advantages over traditional radio signals. It would be persistent, lasting for years or decades, rather than the brief moments of a radio transmission. It would be unmistakable to any species that had developed astronomy, requiring no common technological standard or shared understanding of electromagnetic principles. Most importantly, it would carry information in the very structure of the phenomena, encoding meaning in orbital mechanics and fragmentation patterns rather than in abstract symbols. The language of the sky might operate through what we could call sculptural time, communication through the three-dimensional arrangement of objects across four-dimensional spacetime. Each multiplying event would be a word, each orbital relationship a grammatical structure, each pattern of fragmentation a concept too complex to express in linear language. The full message might only become clear when viewed across months or years of observation, as the objects moved through their predetermined choreography. From this perspective, our modern instruments might be learning to read a language that shamans and navigators recognized intuitively, but could never fully decode. The multiplying phenomena would represent sentences in a cosmic text, meaningful patterns embedded in the apparently random events of natural astronomy. The intelligence behind such communication wouldn't need to visit our solar system physically. They could compose their messages across interstellar distances, timing the arrival of objects and the triggering of fragmentation events to create readable patterns for any civilization that learned to look. The hollow silence we've experienced in our search for extraterrestrial intelligence might result from our assumption that communication must follow human models' brief signals transmitted across space. But intelligence that operates on galactic timescales might prefer to communicate through patient manipulation of physical systems, encoding their messages in phenomena that unfold over decades or centuries. As we continue to observe the multiplying objects, as we track their movements and document their fragmentations, we might be learning to read the first sentences in a cosmic language that speaks through orchestrated reality itself. The question isn't whether intelligence is trying to communicate with us, but whether we're developing the literacy to understand what the sky has been saying all along. In the high mesas of the American Southwest, Hopi elders still speak of the blue star Kashina, a prophecy that describes a time when unusual objects will appear in the sky, heralding the end of one world and the beginning of another. According to this ancient tradition, the appearance of these celestial visitors will coincide with humanity as greatest, test a moment when our species must choose between spiritual growth and material destruction. The prophecy encoded in ceremonial knowledge, preserved for over 1,000 years, describes phenomena that sound remarkably similar to what we observe today. Objects that multiply across the sky, fragmenting and reorganizing in patterns that suggest intelligence beyond human understanding. Half a world away, in the frozen reaches of Scandinavia, Norse mythology tells of Ragnarok, the twilight of the gods that begins when the sky itself starts to fall. The prose Edda describes how the final age will be marked by wolves devouring the sun and moon, stars falling from their fixed positions, and the very fabric of reality unraveling as cosmic forces beyond mortal comprehension reshape the universe. Modern scholars interpret these as metaphorical descriptions of social collapse. But what if they preserve memories of actual astronomical events, moments when the sky genuinely appeared to be falling apart? The Hindu concept of cosmic cycles operates on scales that dwarf Western notions of historical time. The Kali Yuga, a current age of darkness and confusion, is said to last 432,000 years, a span that encompasses the entire development of human civilization and extends far into our future. According to these traditions, each cosmic cycle ends with phenomena that dissolve the boundaries between worlds, when objects from higher dimensions manifest in physical reality, and the normal laws of physics give way to forces that operate according to consciousness rather than mechanical principles. These aren't isolated examples, but part of a global pattern of prophetic traditions that describe end times, scenarios involving unusual celestial phenomena. Mayan texts speak of the return of Kukulkan, marked by serpents of light that dance across the sky. Aboriginal Dreamtime stories describe the rainbow serpent's return, when the ancestors will manifest as visible patterns in the heavens. Islamic prophecy speaks of signs in the sun and moon that will announce the approach of the final judgment. What unites these diverse traditions is their focus on sky phenomena as harbingers of cosmic transformation. They don't simply predict unusual astronomical events. They describe these events as communications from intelligences that exist beyond normal human perception. The multiplying objects in our skies might represent the modern fulfillment of prophecies that have been guiding human spiritual development for millennia. Consider the precision with which some of these prophecies describe astronomical phenomena. The Hopi Blue Star prophecy specifically mentions objects that appear as dancing lights that multiply and fragment, and that seem to communicate with each other across vast distances. The Norse Voluspa describes the end times as beginning when the bonds will break and scattered objects will find each other again, language that could easily describe the fragmentation and reconstitution patterns we observe in the multiplying phenomena. The Hindu texts are even more specific, describing Vimanas, flying vehicles that could split into multiple parts while maintaining coordination, craft that could become invisible by manipulating light, and technologies that operated through the direct application of consciousness to matter. These descriptions, preserved in texts thousands of years old, provide what might be instruction manuals for recognizing advanced technologies when they finally manifest in our reality. But perhaps most intriguing is the shared timing these prophecies describe. Multiple traditions suggest that the phenomena they predict will become visible during humanity's transition from one stage of evolution to the next. The Hopi speak of the movement from the fourth world to the fifth world. Hindu cosmology describes the transition from Kali Yuga to Satya Yuga. Norse mythology tells of the new world that will emerge after Ragnarok. All suggest that the unusual sky phenomena serve as both announcement and catalyst for humanity's next evolutionary leap. From this perspective, the multiplying objects might not be alien visitors or natural phenomena, but something far more profound, manifestations of cosmic intelligence that has been guiding human development across millennia, finally revealing itself directly as our species approaches readiness for the next stage of consciousness. The prophecies would serve as preparation, helping us recognize the phenomena when they appeared and understand their significance for human evolution. The mathematical precision embedded in these prophetic traditions suggests they might preserve actual instructions for interpreting cosmic communications. The Mayan long count calendar pinpointed 2012 as a moment of cosmic transition, but perhaps the real significance lies not in that specific date, but in the period of awakening. It initiated a time when humans would develop the technological sophistication to recognize intelligence operating on cosmic scales. as we watch the multiplying phenomena unfold across our skies. As patterns emerge that seem too coordinated for pure chance, yet too complex for easy understanding, we might be witnessing the intersection of ancient prophecy and modern observation. The myths weren't simply stories about the future. They were maps for recognizing the cosmic intelligence that has been present all along, waiting for humanity to develop eyes capable of seeing its manifestations. The question these prophetic traditions pose is profound. Are we prepared for the transformation the sky phenomena announce? The myths suggest that recognition is only the first step in a process that will fundamentally alter what it means to be human. The night is crystal clear as you step outside, tilting your head back to take in the vast dome of stars that has captivated human imagination since our species first learned to wonder. But tonight, something is different. Mars hangs low on the horizon, burning with an intensity that seems almost aggressive, its red light pulsing like a cosmic heartbeat. Above it, scattered across the constellation of Orion, dozens of points of light that weren't there yesterday move in slow, deliberate patterns against the fixed background of ancient stars. You're not alone in your observation. Across the world, millions of eyes are turned skyward tonight, drawn by news reports and social media posts, by word-of-mouth accounts, and the simple human instinct that tells us something momentous is unfolding above our heads. The multiplying objects have reached a density that makes them visible to the naked eye, a celestial traffic that no one can ignore or explain away as instrument error or wishful thinking. The official statements from astronomical organizations have grown increasingly tentative. Where once they spoke with confidence about natural fragmentation and well-understood physical processes, now they hedge their explanations with qualifiers and uncertainties. The objects don't behave according to the models. Their fragmentations follow patterns that seem too organized for random breakup. Their orbital mechanics suggest coordination that challenges our understanding of how debris fields evolve in space. But perhaps most unsettling is the timing. As if responding to some cosmic conductor's baton, the phenomena have intensified as Mars reached its closest approach to Earth in decades. The red planet, now brighter than it has been in living memory, seems to serve as a beacon for the multiplying objects. They cluster near it, fragment around it, and arrange themselves in configurations that make Mars appear not like a dead world, but like a hub of activity that extends far beyond its atmospheric boundaries. Religious leaders worldwide struggle to interpret the phenomena through their various theological frameworks. Some see signs of divine judgment, others evidence of divine intervention. New Age spiritualists speak of ascension and cosmic consciousness, while fundamentalists warn of end times and final reckonings. The phenomena seem large enough to accommodate all interpretations while confirming none, like a cosmic Rorschach test that reveals more about the observer than the observed. Scientists continue their measurements and calculations, but their instruments reveal patterns that resist easy categorization. The objects emit no radio signals, produce no heat signatures different from natural space debris, and follow trajectories that can be explained by conventional physics, except for the troubling fact that they seem to follow too many different conventional explanations simultaneously. Some fragments behave like ice sublimating in sunlight, others like dust responding to solar wind, still others like particles influenced by magnetic fields that shouldn't exist in interplanetary space. Children point at the sky with the casual acceptance that marks their relationship with mystery. They don't need explanations for the dancing lights. They incorporate them into their games and drawings with the same ease they once reserved for clouds and rainbows. Adults find the phenomena more troubling, perhaps because we've learned to expect the universe to behave according to rules we understand. The multiplying objects suggest that those rules might be incomplete, that reality operates according to principles we haven't yet discovered or admitted. As you continue watching, you notice something that makes your breath catch in your throat. The objects are forming patterns, not random clusters or debris fields. but organized structures that seem to pulse and shift with intentional rhythm. One group arranges itself into a configuration that resembles a spiral galaxy, while another creates geometric forms that shift between triangles, squares, and complex polygons that would challenge a mathematician to describe. The patterns persist for minutes at a time before dissolving and reforming into new configurations. It's as if the night sky has become a vast display screen, and something is using the multiplying objects to write messages in a language of light and motion. You find yourself wondering what mind could conceive communications on such a scale. What intelligence could orchestrate phenomena across distances measured in millions of miles? The implications settle on you slowly, like cold seeping through insufficient clothing. If these are messages, they're being broadcast to the entire planet simultaneously, visible to anyone with clear skies and the curiosity to look up. This isn't the kind of contact that comes through radio telescopes or research facilities. It's contact that bypasses governments and institutions, speaking directly to individual human consciousness through the most ancient medium of all, the dance of lights across the night sky. But messages require interpretation, and interpretation requires wisdom that our species might not yet possess. The patterns in the sky might be greetings, warnings, invitations, or something else entirely, concepts for which we have no words, because we then never encountered the realities they describe. We might be witnessing intelligence trying to communicate across a gap, not just of space and time, but of consciousness itself. As dawn approaches and the multiplying objects fade into the brightening sky, you're left with questions that will outlive easy answers. The phenomena continue whether we understand them or not, patient and persistent, writing their messages across the cosmos in a language we're only beginning to learn to read. The universe, it seems, has decided it's time for humanity to expand its vocabulary. And tomorrow night, the sky will have new words to teach us. The multiplying objects continue their celestial dance, patient and persistent, waiting for humanity to develop the wisdom to read the language they're writing across the stars. In observatories and backyards around the world, we watch and wonder, knowing that we stand at the threshold of understanding something that will forever change our place in the cosmic story. The sky keeps its secrets, but it's beginning to whisper them to those who know how to listen.